Hello, madam. Hello, madam. Am I audible to you? Good morning, everyone. I hope I am audible to all of you. Good morning, Ajay Nanda, sir.
Good morning.
Sir, we are having right now around 10 participants. We will be waiting for a few more minutes.
Actually, can I able to test my slide little bit?
Yes, sir. I'm making it a presenter now. So now you can share your slide.
Is my slide is visible?
Yes, sir. Machine learning and seismic signal processing. It's changing also.
Okay. And just a minute. If I am writing, then is it visible?
Yes, sir.
Red color pen?
Yes, sir. You are marking.
Yes, yes, yes. Okay. Okay then.
Okay, sir. Good morning, everyone. Welcome to day 6 of this online joint faculty development program on machine learning application in signal processing and communication engineering, organized jointly by EICT Academy, IIT Guwahati, NIT Patna, MNIT Jaipur, IIIT DM Jabalpur, IIT Roorkee, and NIT Warangal. Today we are having first lecture on machine learning in seismic signal processing by Dr. Satyasai Jagannath Nanda sir from MNIT Jaipur. Before we start, we would like to share his brief profile with you all. Dr. Satyasai Nanda sir is a senior member of IEEE and assistant professor in the Department of Electronics and Communication Engineering, Malawiya National Institute of Technology, Jaipur. Dr. S.J. Nanda sir is an assistant professor, as we have already shared. Before joining MNIT Jaipur, he has received his PhD degree from School of Electrical Sciences, IIT Bhubaneswar, and MTech degree from Department of Electronics and Communication Engineering, NIT Roorkee. He was the recipient of Canadian Research Fellowship, GSEP, from Department of Foreign Affairs and Intern Trade, Government of Canada for the year 2009 to 2010. He was awarded Best PhD Thesis for SOC Pros 2015 by IIT Roorkee. He received the Best Paper Research Award at SOC Pros 2020 at IIT Indore, IC3 2018 at SMIT Sikkim, SOC Pros 2017 at IIT Bhubaneswar, IEEE UPCon 2016 at IIT BHU, and Springer OWT 2017 at MNIT. He is the recipient of prestigious IEI Young Engineers Award by Institute of Engineers, Government of India in the field of electronics and telecommunication engineering for the year 2018 and 19. Dr. Nanda sir is a senior member of IEEE and IEEE Computational Intelligence Society. He has received travel and research grants from SCRB, UGC, CCSTDS, INSA, INAE. Till date, he has published 40 SCI Scopus journal articles and 40 international conference proceedings, which received almost 1,200 citations. He is in charge of Digital Signal and Image Processing Lab at MNIT Jaipur. Under his supervision, at MNIT Jaipur, 6 research scholars have been awarded PhD and 4 researchers are continuing their research work. Along with it, he has supervised 20 MTech theses. Dr. Nanda sir is a coordinator of Electronics and ICT Academy at MNIT Jaipur, which was set up by Ministry of Electronics and IT, Government of India, with a grant of 10 crore rupees. Dr. Ajay Nanda sir, I welcome you to this program. I made you the presenter. Over to you, sir.
Thank you for giving a warm welcome and introducing me. Today I will be discussing about the application of the machine learning technique in seismic signal processing. This particular topic I have been working from it's almost around 8 years, 7-8 years. So especially this field has a lot of applications and many tools have been employed for the total domain of seismic signal processing. But in this particular talk for the next 1 hour, I am going to discuss about only one problem of it. That is declustering of an seismic catalog. Among the many prediction analysis, then time series forecasting, many problems are there in seismicity, but I will be focusing on this single problem. So this problem I started research work with the GESP fellowship at Department of Earth Sciences, University of Western Ontario, along with Professor Christy Tiampo and Professor Lalu Mansinha. Professor Christy Tiampo is presently the Director of Earth Science Observation Center, University of Colorado, USA. And Professor Lalu Mansinha is a Professor Emeritus at Department of Earth Science, University of Western Ontario. And he is the inventor of popular Stockwell transform. So you know the seismic thing is very, very important because it is a natural disaster and its after effects are trivial. It creates a huge damage to human lives, properties. So are there now mechanism to with which we can able to uh, do prediction of earthquake as well as or we can able to say that we can able to develop a model which can say that if a earthquake comes, how much amount of hazard will happen in a particular region. That is known as hazard analysis. Also, construction of earthquake resistance building is, of course, a challenging problem of civil engineering. So this is a very important article published at New York Times in 2018 that AI is helping scientists to predict when and where the next big earthquake will be. So how we are going to analyze a particular earthquake data? So over here we will be discussing about a earthquake catalog which records the various earthquake happened in a specific region. And this particular data is collected at the seismic centers. Government of India has also deployed many places and created the infrastructure for collecting these data, local data. Uh, so over here, you can observe that it is a record of the date and the time on which the recording has been taken. It has a latitude and longitude which represents at what location the thing has happened. It has a magnitude which has been recorded in Richter scale, and there is a depth information in kilometer. Okay, so all these kind of data gets recorded over the time, and we have to analyze this particular data and find out significant inferences out of it. So there are certain important features of the earthquake catalog which I want to highlight you, that whenever a seismic signal comes, it comes like this. There is a primary wave which first initially hit a particular location, that is known as P wave. Then there is a secondary wave that again hit the same location of the region. Okay, so that's why whenever we get a tremor of the earthquake, we always used to say immediately vacate, because again there is a high possibility that within fraction of second there will be another wave that will be hit that tremor hit region, and that followed by surface waves. Okay, so once in a particular region the seismic waves hit, the tremors of the seismic wave felt over months. In the Nepal earthquake, which happened at the Gorkha, which has caused a lot of devastation in that particular religious city of Kathmandu. So there people felt the tremors of the earthquake for 3 months. Almost for 90 days they felt the shakes over the time, not regular, but over the time. So you can understand the impact of this tremors. Then there is second important thing is magnitude, which is normally measured in the Richter scale. More than 5 magnitude is you can feel it in an effective manner, and more than 6 and 7 that cause huge devastation. Another important parameter is focus or depth. Under what depth the origin of the earthquake happened, how much depth from the surface. Is it within the 70 kilometer from the surface of Earth, or it is below than that? So they based upon this type of depth, there are two kind of analysis. One is shallow earthquake events, another one is deep earthquake events. So deep earthquake, both of their regions of occurrence are different. Deep earthquake events which occur more than 70 kilometer of Earth's surface, they are because of the natural volcanic eruption, because of the movement of the plates between the earths, and because of those kind of events which happen normally at a very intense core of the earth plate, and which occur and there are other regions which happened within 70 kilometers, like some land mines explosion, and sometimes because of the coal mines digging, and because of all those things also earthquake happens. So this is a pictorial representation of the focus of the earthquake and the hypocentral distance from the point of interest. Point of interest means where our recording is being takes place. The earthquake signals are being recorded at the point of interest. Okay, and epicenter is a point which is directly very close to the focus of the particular earthquake which has happened. So everybody ask about the epicenter. That means where the earthquake has happened. So I told that location or epicenter is very, very important, which can be calculated based on the time at which you are receiving the signal at the recorded center. And from there, you can consider and calculate the location of the epicenter. So this is two signals I am showing you. One is recorded at the Tohoku earthquake of Japan, in which nuclear reactors have been also broken down, and there was a huge loss for Japan, and it was heavily affected. And the Gorkha earthquake of Nepal. So you observe these two things that one happened on 11th March 2011 and another on 25th April 2015. You see this black dot. This black dot is the main shock. Okay. On the left side, it is a magnitude of 9 and above. On the right side, it is a magnitude of nearly 8. And before to that, some events have been marked as red. They are before they are the event, they are known as foreshocks. They happen before to that particular earthquake. And once this particular main shock arises, After that, a lot of tremors get felt, and they are known as aftershocks. So you can able to observe that once the main shock happened, there is a trail of aftershock, blue points immediately after that. So that signifies the immediate occurrence of a lot of events after that. So this is the pattern analysis of the earthquake events. That this is the energy concentration on the left side in latitude versus longitude. You can able to observe that patterns and deep black events that shows the energy concentration of the earthquake at of 9 magnitude at Tohoku of Japan. And the right side is another plot which shows you that it is a magnitude versus time plot, which says that the 9 magnitude event, which is very highest, that has occurred only one time. That means the main shock in a particular region that happen very rarely, or you can say one or two events that has very high magnitude that occurs, and after that the number of low magnitude events, they are more. So first event is 9 magnitude, next one is 8 magnitude, then 7 magnitude, then you see the number of events increase. Okay, and it is exponentially increasing number of events of lesser magnitude. Okay, so higher magnitude events occur very low and lower magnitude events occurs more frequently in that particular analysis. So it is represented by a Bath law. So this is the left side is Tohoku and Gorkha earthquake that we are analyzing. This is another analysis that represent how the events have increased over the time, and there once the events occurs, then the number of events that follow a deviation from linearity. You observe that this black curve, they are not linear. If the even number of events every year occurring is uniform, that would have been probably a linear curve, but that is not linear. So this signifies that there is a non-linearity pattern that occurs in a particular region of seismicity. So our objective over here is you can observe that most of the earthquakes, they follow a pattern like this, that there are certain events which occur before to this particular main shock, and there are a trail of events after the aftershock. So we have to analyze this particular thing effectively, so that if we can able to recognize these main shocks, and before to that these four shocks, if we can able to recognize, then we can able to make a prediction of the main shock, as well as once the main shock is happened in a particular region, we can able to think about the aftershock and perform a hazard analysis. So for this particular thing, another very important task is known as background events. What is the importance of background events? That these events occur regularly due to the movement of Earth's surface. So Earth's surface is moving, Earth is constantly rotating. So because of that, some events get generated regularly of low magnitude, but they normally gets generated. So we have to discard all those kind of events and make a perfect analysis of those events which have generated due to the particular quake in a particular region. So that's why we call this particular effect is known as declustering. So why we are going for this declustering? Because we can able to do a probabilistic hazard analysis model development, and it is very important uh, for unbiased and stable estimation of long-term seismic activities. And it also helps us to get the best possible estimate of the rate of main shocks that requires a catalog of independent events. It also helps us to forecast the location of large earthquake events. There are many challenges are there to analyze this particular seismic signal, that we have to consider various different assumptions, and the algorithms assume a lot of things on the recorded data. As a result, any particular algorithm you are applying that may or may not be suitable for that particular region, because each region has a different characteristics. Its soil nature is different. Its characteristics is different. So one particular way of analysis which is effective in a particular region of India, that may not be suitable for California, and whatever is suitable for California, that may not be so effective for Japan, because all the three regions do have different characteristics. And there are many methods have been reported by the scientists, and some of the models, they do lead to a high variability in the estimation of the background seismicity, and thus it affects the long-term seismic hazard assessment in a particular region. So our objective over here to build some of a robust and little bit robust, we can able to say novel declustering technique that may able to suit for some of the regions, some of the seismic regions. So all of you know about a data clustering concept. If we have a data set of n cross t, that is n number of patterns are there, and that is n number of events are there, seismic events are there, and each event has d number of attributes, then we are going to cluster this particular catalog into some m number of groups, into some m number of clusters. Okay, so there are n number of events are there, seismic events are there, and we are going to categorize it into m number of groups, m number of clusters, in such a way that you will define a earthquake cluster such a way that none of the clusters should be empty. If if a cluster has only 0 element, then you cannot able to say it as a cluster. Between two different clusters, there should be no common element. That means the clusters are disjoint in nature, that you can able to define. Then suppose in a catalog there are 1000 event. Okay, 1000 event, and I have divided it into 5 clusters. Then the summation of all these 5 clusters, that will equal to the total 1000 events. That is the summation of all these small clusters that we have divided. Their summation gives to the entire catalog. So this cluster formulation is formulated as a optimization problem, that you have to define a statistical tool which will do the clustering. Okay, so normally what we do is we define some of the leaders, some of the cluster centers, and each element of the particular seismic catalog, we associate them with those cluster centers. Okay, or we can able to say that we are defining a function that will relate each of the element of this catalog to that particular centroid. Okay, one of the very popular method is k-means clustering, which is very popular among all researchers and scientists, that says minimization of Euclidean distance between element of a dataset and their corresponding cluster center. So if you are taking a particular dataset, then from the dataset, this is a Irish dataset, okay, and it has 4 patterns: sepal length, sepal width, and fetal length and fetal width. And we have taken some of the features. Suppose it has been it has 150 element, and we are going to take its suppose we are going to divide it into 3 clusters. Okay, so this 3 clusters have been taken randomly: Z1, Z2, and Z3. Okay, then we determine the Euclidean distance. Okay, so from each pattern P1 to Z1, that leads to the cluster D11, P1 to Z2, that leads to cluster D12, P1 to Z3, that leads to D13. So among D11, D12, D13, D11 is lowest. So sample 1 has been assigned to cluster C1. Similarly, for the second pattern, again we calculate the distance from all the 3 cluster centers, and D23 is found to be less. So the second pattern is assigned to cluster 3. So like that, for all 150 patterns that are present in the data set, they have been categorized into either C1, C2, or C3. So suppose now among these 150 points, suppose 40 has been categorized into C1. Okay, then for all the 40 patterns that belongs to C1, then from there we take the average of each of the pattern. That defines the updated value for Z1. Similarly, we update the value of Z2 and update the value of Z3. Like that, the process goes on, and we will continue it until and unless we find no more change in Z1, Z2, and Z3 positions. So this distance I told you, D11, D12, and D13, that the Euclidean distance we are calculating between each point to the cluster center. So we are calculating this particular Euclidean distance and trying to minimize. How many data points are there? From those many data points to those many cluster centers, you are calculating the distance. That means if we have taken 3 cluster centers, then 150 cross 3 distance you have to calculate. If you have taken 4 cluster centers, 150 cross 4, those many distances you have to calculate in each iteration of the algorithm. So over here, based on this particular concept, we have proposed a tetrastage cluster identification model for this analysis of seismic catalog. And there are 4 stages of clustering that have been employed in this. One is based upon depth, time, coordinate, and magnitude, considering these 4 type of category of features. And we have analyzed this particular model for the seismicity analysis of Himalaya, Japan, and Taiwan. So you observe that in this particular algorithm, we have proposed that a earthquake catalog that has been taken into analysis, that is segregated into 2 parts based upon the depth. There is a depth threshold is there, on which we have segregated them into shallow focus earthquake event and deep focus earthquake event. Okay, so I told you that it is whether it is less than 70 kilometer of radius or it is more than 70 kilometer of radius. Okay, so if it is occurring more than 70 kilometer of radius, then we are defining it as a deep focus earthquake event. And then that particular event we are again segregating with respect to a magnitude threshold, that whether the event has more than 6 magnitude or it has less than 6 magnitude, then we are defining them based upon that is a deep focus earth aftershock event or that is a deep focus background event. The deep earthquake event, whether they fall under the aftershock or they fall under the background, that is associated with a event which has occurred due to earthquake, or that event is occurred only due to the regular movement of earth. Now these swallow focus events, that maximum many earthquake events are nowadays swallow focus, that is mostly created or related due to the human centric activities, that is within the 70 kilometers, and for them we are saying that it is occurring with respect to time. So we have to take the time information into account, and on this step 2 we are doing temporal cluster analysis, and from there we are defining that how the particular temporal clusters, whether it is a regular with respect to the time analysis or whether it is a danger time analysis. Okay, and along with that we are now then further we move ahead from time domain to the space domain, in which we are doing the space domain analysis, in which again we are categorizing the event with respect to space, whether they are regular in nature or whether they are danger in nature. So after that, we do magnitude based analysis. So thus the entire thing has been categorized into 4 different stages of analysis. So this is the Himalayan seismicity you can able to observe, and it has been downloaded from advanced, this seismic catalog is downloaded from Advanced National Seismic System NCDC, with setting this particular uh, information of latitude, longitude, time of arrival, magnitude, and depth, and the total number of events for analysis is taken out to be 16,253 events. So this is based upon the depth thresholding. You can observe that the left side is the shallow focus events and the right side is the deep focus events, and the depth threshold is taken 70 kilometers. Then from those events we have found it out that the shallow focus events, they are 9 in nature, and you can observe that the Gujarat event of 2001, Nepal 2015, Andaman Nicobar Islands 2005 and 2009, and the Kashmir event, Uttarkasi event. So all those events are recorded. In all those areas, the devastating earthquakes have happened. Then this is the analysis with respect to time zone, that from 1990 to 2015, that the number of almost around 12,000 events, how they occurred, and the red color dots, they are the occurrence of the main event, and the impact of the clusters that has been highlighted over here with different colors on the left side. And among these different colors you are observing, there is on the right side, there is a time zone clustering, which says that how much is the impact of this particular thing over the period of time, which is danger in nature. The black one is danger, and the rest of the colors are not that much danger in time. So the among the total to near about 12,000 events, there are 7,000 events that occur on the danger time zone, and some 4,500 events they are occurred in regular time zone. Then after the time, this is the space analysis, and you can observe that on the left side there are different colors. The events which are located, they are associated with this particular black color peaks, and the correspondingly the impact of the particular high sensed locations have been shown. Among these particular zone, this the leftmost one, you can able to observe that there is a black color point, and on its in and around surrounding yellow color points are there. So these yellow color points have been impacted by this black color main magnitude event which occurred there. And among these yellow color events, now this red color dot and this black color dots you can observe. These black color dots are the high impact danger with respect to coordinate events which we have able to find it out. And the entire yellow events, they have related to this black color event, this red color event, but the black color ones are the really dangerous one with respect to this space. So we have found it out that with respect to time, there are events which are danger in zone, and with respect to space, there are events which are danger in zone. And then further, we have taken into consideration of different category that different category of clusters that which are danger in time and regular in space, danger in time and mm, danger in space. Both the thing, they are really aftershocks. Then so based upon these two categories, we have further classified the entire set of events into 4 categories. So which are not really dangerous with respect to time and coordinate, we are saying that they are backgrounds. So these events further gone on analysis to the next stage, in which we apply a magnitude threshold based uh, analysis for defining them as backgrounds or aftershocks. So this is the cluster identification on the seismicity of Himalayan seismicity. So this is after the final analysis. These are the events which are categorized as aftershocks on the left side, and on the right side, the events are background in nature. So what is the difference? You can able to clearly observe with this particular thing that with respect to like longitude and years, you can observe that aftershock events, when they occur after this red color, after this black color point, there is a trail of events that has occurred on this time. So over here also you can able to observe that after this occurrence there is a trail of event. After this occurrence there is a trail of event that has occurred. Okay, but background event, they have occurred uniformly almost throughout the entire region. So this is the lambda plot for analysis over the years. You can observe that in 2005 and 2010, there are peak number of events they have occurred over here. Okay. And our model analysis that also saying that these are the total number of aftershocks that have been categorized. And this other curve is showing the background events. Okay, so background events are almost uniform in nature. They are not getting so much triggered by the aftershock events. So further analysis have been done on Japan and Taiwan catalog on this similar manner, and the methods have been compared by the proposed tetrastage analysis model compared to the other statistical benchmark models which have been reported by other scientists like Gardner-Klopp and Unharmer. So this model finds to accurately classify the events and do not overestimate the background events. So that in this particular analysis, we have taken into account the cluster analysis based on time, space, and magnitude depth for the analysis. And effective results have been reported. But I told you that the clustering has been formulated over here as an optimization problem. So when you deal with a optimization task, there are many particular methods have been reported by mathematical scientists for the analysis, like Newton-Raphson method, Gauss-Jordan method, steepest descent method, many methods have been reported, but these are derivative based methods, and in many of the times derivative methods do fail when the problem of analysis takes care of a multimodal function into account. So you know this is the fundamental of the optimization, that on a particular curve when you are going to optimize, then you go on taking the derivative until and unless slope changes either from positive to negative or from negative to positive, and there you declare it as a maxima or minima. But whenever it is a multimodal function, the derivative gets stuck at local optima and declare them as the optima, where the global optima that lies at a different location. So to solve this type of problem, like this is an example that multimodal surface having different maxima and different minima, that over here 3 maximas are there and 2 minimas are there, and our objective is to determine the total peak and the total valley. So for this type of thing, nature inspired optimization algorithms have been also reported by the scientists, in which we employ different type of creatures like birds, ants, different natural agents whom we consider as a solution for this particular problem. And you can observe that on this particular multimodal curve, we have employed 6 elements. So if there is a possibility that element 1 or 2 get stuck in the particular local optima, so there is more chance that any other element they can able to find the global maximum. And these elements, they are interactive in nature. They collaborate among themselves. They used to interact among themselves. So this is also known as a way of collaborative learning, in which the solutions do get improved over the time. So you know that there are many benchmark functions which do possess such type of multimodal characteristics like egg holder, drop wave, alpine, Greenwich, Rastijin, De Jong. All these functions you observe that they are multimodal functions in which there are many optimize are there. So to solve such type of problem, we need to take care of these nature-inspired optimization algorithms. And these are some of the popular researchers all across the globe who have contributed much to this nature-inspired optimization-based algorithm. One of the popular person is Professor Kalyan Dev, who is the director of Coin Laboratory at Michigan State University, USA. You can refer to his website of Michigan State University. Earlier, before joining Michigan State University, he was a professor at IIT Kanpur, and he developed a very good research laboratory of IIT Kanpur Genetic Engineering Lab. You can also visit to his website. He has popularly developed the algorithms of non-dominated sorted genetic algorithm version 2 in 2002 and version 3 in 2013 and 14. So with these two algorithms are very popular. So if you want to apply those algorithms, you can download their corresponding research papers as well as codes also from his website. Then another very popular person is Professor Sanghamitra Bandyopadhyay, who is the director of Indian Statistical Institute, Kolkata, and his research website also from ISI Kolkata. You can get data as well as the recent publications on the nature-inspired algorithm applied to various clustering algorithms she and her research group has developed. Another popular person is Professor Marco Dorigo, and he is there at University of Brussels, Belgium, and you can able to refer this particular website. And he is the inventor of ant colony optimization, which is another very popular algorithm. Renner Strawn and Kenneth Price, they are also contributed much to this particular society. They are the inventor of differential evolution algorithm, and you can refer to this particular website for the update in this particular field. And here I have highlighted some of more of the nature inspired algorithms which have been employed for the clustering. They are basically categorized into evolutionary algorithms that the naturally how the survival of the fittest that happens over the time. That means dinosaurs were surviving once upon a time, but human beings were there at that time, but now human beings are there, but dinosaurs does not exist because with respect to the change in environment, they could not able to make them survive. So survival of the fittest, according to Darwin's theory of evolution, these all algorithms have been developed. The genetic algorithm, evolutionary strategies, genetic programming, differential evolution, all these researchers who have invented these algorithms, I have marked them. And when it has been applied for solving this clustering problem, that also I have marked them. I have told you about Professor Sanghamitra Bandyopadhyay and other group members who have also applied these particular algorithms multi-objective versions. That means we are not only employing this Euclidean distance is one particular method for analysis, means one particular function. Like that you can use correlation maximization, you can use Davis-Bode index, you can use Silhouette index. There are many other statistical functions which you can either maximize or minimize to solve this particular clustering problem. And when you take use of more than 2 or 3 statistical functions for analysis, and those functions are contradictory in nature to each other, then you call that one as a multi-objective optimization. That you are not only minimizing Euclidean distance, but simultaneously maximizing the correlation coefficient, simultaneously minimizing, suppose, variance ratio criterion. So like that, 3 or more statistical function you are using simultaneously, then that is a multi-objective optimization problem for doing the cluster analysis. And along with that, there are physical algorithms are there. Popular are simulated annealing based algorithms, memetic algorithms. These things have a special characteristics. These type of algorithms have been inspired from physical phenomena, like what happens in our surrounding. One of the popular such algorithm is gravitational search algorithm. How the gravity between different planets, they balance each other so that an optimized way there is force balance between everywhere. So inspired from that particular phenomenon, a gravitational search algorithm has been reported. So like that, a lot of algorithms have been reported. There is swarm intelligence, another very popular thing I was talking about. Professor Marco Dorigo, who is the inventor of ant colony optimization algorithm, swarm intelligence, in 1992, and it's a single objective, multi-objective, both versions have been applied for the clustering task. So it is the inspiring phenomenon observed from various animals who work together to solve a particular task. Like many ants, they formulate a single queue. So the from the food source to the particular hole, they always travel in a queue, because they have to take the foods from the food source to their holes, and the queue they form, that is an optimal path between the source to the destination. They always travel to move in a particular straight line, and that particular line is optimal. That is observed by Marco Dorigo. And how they formulate, they collaborate among each other to formulate that particular line. So that is the behavior of collective behavior of a group of agents, that is known as swarm intelligence. Now, there are bio-inspired algorithms also, like artificial immune system. In this COVID scenario, everybody talks about the immunity. Can we talk about artificial immunity? Can we think about the immune inspired algorithms? They can able to protect our networks, our particular LAN WAN connections, and we can make the things more secure. That is also a optimization based algorithms. We can able to get inspiration from these principles, and we can able to develop. So many of these algorithms have been reported, and these are the steps overall I have compiled of the nature inspired algorithms to solve a optimization clustering problem. So if you are going through the first one, that is a genetic algorithm, you have to initialize chromosomes, then you have to perform crossover, you have to perform mutation, you have to do fitness evaluation, then you have to go selection, and then determine the final cluster characteristics, and then make a, for the next generation, make a loop and go ahead until and unless you are obtaining your desired solutions. Like that, many of these algorithms, they have followed their own principles for solving the clustering problem. So like I told you that Euclidean distance minimization. So there are many other statistical functions over here you can observe, like midpoint distance, centroid distance, distorted distance, variance ratio criteriation, intra and intra-cluster distance, Dunes index, David-Bodin index, CS measure, Silhouette index, many other things. Either they are minimization or maximization. That gives you effective clustering, which you can apply to solve the declustering problem of seismicity analysis. So this is a review research paper I have written along with my supervisor, Professor Ganapati Panda from IIT Bhubaneswar. So this paper in the last 4-5 years has gained more than 500 citations. So people are referring this particular paper for the analysis and the applications of the nature-inspired algorithm for the clusterings on seismicity and for other applications also. So, like I told you, many of the algorithms, this is one recent article which we have published, inspired from the gray wolf optimizers. So, how it is inspired from the pack of gray wolves. They move on a pack and they find out the prey and try to chase it from all the aspects by encircling it and then going near to it, and that is formulated as a optimization problem. So over here you can observe that some of the gray wolves like alpha, delta, omega, such type of wolves, they all are trying to move where there is a prey is there at the bottom of this particular surface. Okay, so the wolves do have only one task, that they have to move on to this bottom to find out that this prey is there, and they all will grab that prey. Okay, so this particular algorithm is reported by Saidi Mirzali and their research group. So this is the update equation associated with this particular algorithm, that they encircle the play, they move towards and move away from there, and the entire encircling process is dependent upon the top fitness evaluator group, that is alpha, then followed by the second one beta, and the third one delta, and rest all people's update is taken place from the average of these three things, so that overall pack is moving towards the prey. So based upon this particular gray wolf optimizer, we have formulated a quantum inspired gray wolf optimizer and applied this particular one into the declustering problem of the seismicity analysis. So we have reported, this is a recent paper of 2019. Our group have published this. So here we have taken the TM matrix, variance, and effective ergodicity of the seismic signals into account for the optimization task, and we have used it for analysis of 4 different seismic models of Himalaya, Japan, Indonesia, and Switzerland. And the analysis models I have described you, and they are corresponding curves. So those things, the results have been highlighted over here for the 4 analysis. So you can able to observe that the red ones are the peak results, the entire true catalog results, and the blue one are our observed results. So the blue one is following the pattern of the red one, that is the accurate estimation of our model, and the black one was the regular movement of seismic events. So this is the deviation from the linearity curve that I have discussed with you during the analysis, and that is what a close response matching that has been highlighted over here. And this is the optimization task that is on the all the 4 algorithm, that the gray wolf optimizer performance comparison with the particle swarm optimizer. And this is the comparison of the proposed work on along with the other benchmark models. And the performance is found to be effective compared to those other statistical analysis based models. So this is some of the important publications we have achieved. The IEEE Journal of Selected Topics in Earth Observation and Remote Sensing, Pattern Analysis Springer, Journal of Computational Science, IIT. So you can refer these particular publications of our group for the analysis. And these are some of the important conferences also we have cracked in the last couple of years. So these are some of the important references that have been taken for this analysis. So that much from my side. Any query, I will be happy to answer.
Dear participants, you can raise your hand so that we can unmute you from our side. Nanda sir, there is a query from the participant side. How to find the optimizer? Which one is suitable for a problem?
Actually, there is no specific thing that which particular optimizer will work best for which particular environment. You have to take consideration about the optimizers. Some of the optimizers are effective for online environment. That means like PSO and all. They give you result in a quicker amount of time. And there are some optimizers which are having little bit heavy computational time, but they give you more accuracy. So if your problem is a offline problem, then you can employ a heavy means lengthy optimizer. And if your problem is little bit online problem, then you can go ahead with lesser step based optimizer. They may not be accurate, but they give you quick results. So PSO and Gray Wolf, these are quick. These algorithms give you quick results, but there are other algorithms like social spider optimization, genetic algorithm, and ant colony. They give you. They takes time, but they give you a more accurate result. So based upon your problem, you have to choose the particular optimizer. I
Sir,
hope I
there is
have
a
answered.
sir, there is a query from Rajalakshmi.
Hmm.
Is there data sets for seismic signals?
Yes, there. In this particular slide, you will find a lot of databases I have told, and you can go to those datasets and you can download them from American National Seismic System website. Also, you can able to download. USGS is there. From there, you can able to download some of the publicly available datasets, and so some datasets are not available as well. but there are data sets which are available publicly for the analysis.
Sir, there is one more query. How many type of Euclidean distances method are there?
There are many type of Euclidean distance method are there. They are actually not Euclidean distance, but there are other distances which can be effectively applied, like Manhattan distance. There are other distances also I have mentioned in the slide. Like let me share and tell you a little bit. So these are the thing: midroid distance, centroid distance, distortion distance, intra and intercluster distance. So these are many of the distance type which can be employed for the analysis. These are the researchers who have already taken them for analysis. So I hope I have answered the query. Any more questions?
Dear participants, you can write in the chat box if any queries are there. If you have any queries, you can also mail us in our email ID, which is shared with you in our registration confirmation mail. Thank you, SJ Nanda sir, for such a nice talk
Thank
on
you.
seismic signal processing.
One more thing I want to ask that yesterday there was a mail for sharing the digital signature. I have sent it. So
Yes, sir.
if you can able to confirm that.
Yes, sir. We will check and
Okay,
confirm back to you in your mail ID.
okay, okay. Thank
Thank you,
you.
sir.
Thank you.
Now our next lecture is on machine learning for cooperative spectrum signal sensing. It will be covered by Dr. Kuldeep Singh sir. Before we start the session, we'd like to give a quick introduction of Kuldeep Singh sir. Dr. Kuldeep Singh sir has received his PhD degree in computer vision from Delhi Technological University, New Delhi, and MTech degree in signal processing from Netaji Subhas Institute of Technology. He has worked as postdoctoral fellow at University of Alberta, Canada, where he was involved in the development of deep learning-based functional prototype for agriculture applications. Before joining MNIT, he has worked as Central Research Laboratory of Bharat Electronics Limited, Ghaziabad, as scientist from January 2007 to March 2019. During his stint as BEL, he has worked on various projects of national importance. He was involved in software development of various C4I systems for Indian and foreign defense forces. He has been awarded Research and Development Excellence Award at Bharat Electronics Limited in 2009 and 2011. He is reviewer of various IEEE transactions, Elsevier Springer journals. Good morning, Kuldeep sir.
Good morning, sir.
Uh,
Thank
sir,
you.
welcome to
Thanks
the
for
session.
giving me this opportunity here. So it's freezing cold in Jaipur these days. How's the weather there? Can you hear me?
In Guwahati, it is quite freezing, not that much, sir.
Okay. Here it
In,
is rainy for last 4 or 5 days,
yes,
and
sir.
it's quite a cold weather.
Yes, sir. In Guwahati, it's shining now. Sunshine is there.
Oh, that's good.
Yes, sir.
So can we start the talk, sir?
Yes, sir. I have made you the presenter.
Okay, I'll share the PPT.
Yes, sir. Yes, sir. It is visible.
Just let me put it in presentation mode. I hope
Okay.
this is there in the presentation mode.
Yes, sir. It is visible. Machine learning for cooperative spectrum sensing.
All right, sir. All right. Just give me a moment. All right. So good morning, participants. Uh, Thank you, Professor, for giving a nice introduction about my profile. As far as my research domain is concerned, my main focus is on computer vision and applications of machine learning and deep learning in the field of computer vision. And recently, we have started working on the applications of machine learning and deep learning in the field of wireless communication. A small research group is working in this direction, which includes one PhD scholar and one master's student. So today we are going to discuss the applications of machine learning in the field of spectrum sensing, which is one of the crucial areas in next generation wireless communication technologies. As far as the agenda is concerned, we will briefly discuss the concept of cognitive radio, how it is an enabler in dynamic spectrum sensing. We will talk about cooperative spectrum sensing, the basic concepts of cooperative spectrum sensing, and why it is very important in recent times. There used to be traditional methods for spectrum sensing. What were the major limitations of traditional spectrum sensing methods? Why we are diverging towards machine learning? What are the application areas of machine learning in the field of cooperative spectrum sensing? Why it is important to apply ML for CSS? We will discuss some of the state of the art machine learning algorithms and some popular features which are being extracted from the sensing signals. We will also have a look on some of the simulation results of some machine learning algorithms for cooperative spectrum sensing. Also, we will discuss the limitations of machine learning algorithm, what are the scope of improvements, then migration from machine learning to deep learning, what are different test cases of deep learning in cooperative spectrum sensing. We will also discuss how do we measure the performance of these algorithms in terms of performance metrics. Some of the results will be shown using deep learning. And also we will talk about one or two future research directions which could be of interest for the researchers. As you all are aware, spectrum is a precious asset of any country. If it is precious, we have to handle it carefully. And uh, as per the Cisco annual report of 2020, which was published the status from 2018 to the future predictions to 2023, the mobile subscribers will, the number of mobile subscribers will reach to 5.7 billions in 2023, which was approximately 5 billion in 2018. You can imagine the amount of spectrum access which these mobile devices are going to have. Also, number of devices are going to be increased exponentially. Like there is a prediction of around 13 billion mobile devices will be there in 2023. Also, if there are advancements in the technology, in the wireless technology, definitely the connection speed must be growing. So there is an prediction of, there is an expectation that the connection speed will be somewhere around 575 Mbps by 2023, the 5G connection speed. So considering this volume of subscribers and mobile devices, and also as you are aware in 5G, we will have integration of IoT devices, wearable devices, the tremendous amount of data, tremendous amount of access to the spectrum will create a spectrum scarcity problem. So to address this spectrum scarcity problem and utilize the available resources, we say that the future wireless communication system must support intelligent processing. Also, with the rapid development of next generation wireless communication technologies, the increasing demand of spectrum resources, it is the need of the hour to introduce learning and reasoning capabilities in next generation radio networks. And this scarcity problem has led to tremendous research in the field of cognitive radio. So let's discuss about what exactly is a cognitive radio. Cognitive radio is based on the software defined radio technology. It is an intelligent device. Intelligent in the sense it can adapt to the dynamic changes in the wireless environment. Dynamic changes means change in the transmitter properties, change in the frequency band. So these new age cognitive radio devices are intelligent enough that they can adapt to the dynamic changes in the environment. That is the reason these cognitive radios are the key enablers for dynamic spectrum access networks. And they can be instrumental, they can play a pivotal role in solving the spectrum shortage issue. So whenever we talk about spectrum, there are two major types of users of the spectrum. What are these? One is the primary user, who is the licensed user. The primary user is the licensed user to access the spectrum. But it happens that the primary user is not using the spectrum all the time. So we can utilize those spectrum holes whenever the primary user is not accessing the spectrum. So the other type of the user is the secondary user, which is an unlicensed user, and it opportunistically accesses the spectrum allocated to PU whenever the primary user is not accessing the spectrum. So with the help of these cognitive radio network, the secondary user, which is a cognitive radio device, can sense the spectrum and tune their transmitter to the available channel. In this way, we can have an optimized utilization of the available spectrum. Of course, it is evident, it is prudent that this secondary user, the communication of this secondary user should not bring any interference to the primary user. So basically, this cognitive radio network is helping us in intelligent spectrum management. These are some of the popular, major functions of cognitive radio network. As you can see in this diagram, we have the radio frequency environment. So the first step of the cognitive radio in a network is the sensing of the spectrum. That means discovering the spectrum holes, identifying the free spectrum band. So there is a technique called spectrum sensing. So it enables to detect spectrum holes. Detecting spectrum holes mean in terms of the duration of availability, how long the spectrum is available, how long the PU is not using that spectrum, at what frequency, what channel is available, and at what location. So the spectrum sensing helps us in finding the free spectrum band which a secondary user can access. Next thing is the spectrum decision. Once we have identified the holes, next task is to take a decision on the access of that spectrum, whether the secondary user can access the spectrum or not. Also, it includes the spectrum analysis by choosing the appropriate spectrum bands as per the user's quality of service requirement and decision making. So after a spectrum analysis, the task of spectrum decision is to make a collective decision so that the vacant spectrum bands can be accessed by the secondary users. The spectrum mobility is related to movement of secondary users from one band to another band. We also call it spectrum handoff. So whenever a spectrum band was free, a secondary user is accessing that, and if the primary user has started accessing that particular band, the secondary user has to move from one band to another band, which we call as spectrum handoff. So the spectrum mobility basically performs spectrum handoff and connection management. So whenever the SU needs to switch from one spectrum hole to another on the arrival of the PU, the spectrum, the connection management under the spectrum mobility function ensures continuous data transformation from secondary user in the new spectrum hole. And finally, spectrum sharing. So since the multiple SUs are trying to access the available spectrum, there is possibility of collision between these SUs. So the spectrum sharing basically coordinates among the secondary users so that there is a efficient use of the spectrum. So we talked about spectrum sensing. So spectrum sensing involves making decisions at the individual secondary users. However, in the cooperative spectrum sensing framework, secondary users exchange their sensing results with a common receiver, or we also call it fusion center. So inside a cognitive radio network, suppose there are one or two primary users and multiple secondary users, they share or exchange their sensing results to a common receiver, that is a fusion center, and at the fusion center there is a final decision on whether the primary user is present or not. In the case of individual spectrum sensing, which is being accomplished on the secondary users, the detection of spectrum for a single node is susceptible to error. So it is advisable to involve all the secondary users in spectrum sensing. All right. One of the popular problems in any cognitive radio is the hidden node problem. Due to shadowing and geographical constraints, sometimes the secondary user is not able to sense the primary user signals. or the quality of signals received at the secondary user are degraded. In that case, there could be wrong sensing decisions about the presence and absence of the primary user at a particular secondary user. It seems like the secondary user is hidden. In major practical scenarios, some of the secondary users may go far away from the fusion center or the primary user, and thus they becomes hidden nodes, and they can't participate in the decision making of availability of availability or non availability of primary user. All right, the traditional spectrum sensing methods, one of the some popular traditional spectrum sensing methods are based on NSG detection or matched filter detection or cyclostationary detection. These techniques basically requires optimum thresholds to detect the presence of primary user. These techniques rely on thresholding based methods. There is a threshold. If the received energy is above that prescribed threshold, then we declare that the primary user is available, else it is absent. So deducing, each design has a different algorithm for calculation of these threshold values. It is very typical, it is very complex to define the optimal detection threshold. If the threshold is too high, then it can lead to probability of misdetections. And if the threshold is too low, it can lead to the probability of false alarms. In case of energy detection, we have to estimate the noise power accurately, which is also a challenging task. So these are the major limitations of conventional or traditional spectrum sensing methods. This is the graphical depiction of cooperative spectrum sensing. You can see here, we have a primary user which is transmitting here. These are the secondary users, SU1, SU2 to SUN. These are the decision devices. They capture the sensing signal from the primary transmitter and they report it to the fusion center. And at the fusion center, a collective decision is being taken whether the primary user is available or not. So it is hypothesized in terms of H0 and H1, where H0 is the null hypothesis.
Kuldeep sir,
Yeah, I'm really sorry. There was some network glitch in between, so it got disconnected. I hope you can hear me clearly.
Yes, sir. Now you are audible.
Yeah, please give me the share access again. It has gone somehow.
Okay, sir. I'm just making you the presenter. Sir, you are a presenter now.
Just give me a moment. So yes, we were talking about the cooperative spectrum sensing, where different secondary users contribute or share their sensing information to the fusion center, and the fusion center hypothesize this decision in terms of H0 and H1.
Kuldeep sir, there is some audio issue again at your end.
I'm really sorry, sir. Again, I don't know what's the issue here. I think I'm audible now.
Now you are audible, sir.
Okay. Let me share the screen again then with you. I think you will have to give me the rights again.
Sir, please check. I made you the
Yeah,
presenter again.
sure. Yes. I think the slides are visible now. I'm again extremely sorry for that. Uh, so we were talking about the cooperative spectrum sensing, and the secondary users share their results with the fusion center, and a collective decision is being taken at the fusion center. Next, we'll talk about the system model. I was just telling you at the Fusion Center, this is taken as a two-class problem. This is hypothesized as H0 and H1, where H0 means the PUs are inactive and H1 means at least one PU is active. So this binary hypothesis for spectrum sensing is governed by this system model, where in case of H0, YS is the received signal at the secondary user, and neta S is the noise, the independent and identically distributed noise. In case of H1, where the primary user is active, we are basically receiving the primary user signal as well as some portion of noise. Also, the system model caters the channel condition, the channel gain between primary user and the secondary user. So S is the number of secondary users here. So this is about the system model. And based on this system model, the fusion center takes a collective decision whether the primary user is active or inactive. This is a practical scenario how the secondary users firstly receives the sensing signals. Let me take a pointer here. This is the primary user, and this is a particular cognitive radio network in which we have multiple secondary users, and these secondary users will have multiple antennas. And it might be possible that these antennas are experiencing different kind of fading. So one of the antenna might be encountering relay type of fading. One of the antennas may be experiencing Rician or Webull kind of fading. And further, these secondary users are reporting their sensing matrix, sensing results to the fusion center. And at fusion center, we are basically computing a sensing matrix where each of the element gives us the sensing results of one of the antenna of a particular secondary user. So these rows represents the secondary user index, and these columns represents the individual antennas. As I told you earlier, these antennas can experience different type of fadings. So this gives us some kind of practical scenario which may happen in the real environment, real wireless environment. Now, considering the limitations of traditional spectrum sensing methods, where we have to deduce a optimal threshold, and which was a challenging task, we have migrated. I mean, the research community has attempted the machine learning algorithms in the field of cooperative spectrum sensing.
Kuldeep sir, you are not audible again.
Sir?
Kuldeep sir?
Yes, yes, I am here, sir. I don't
Okay,
know,
sir.
my office router is creating some issue. I think it is restarting again and again. I'm really sorry for that.
No issue, sir. You are the presenter also, sir.
Okay, sir.
No, you got disconnected, sir, I think. Again, I have to make you a presenter. I'll make you a presenter now.
I have connected to a different router this time. Maybe I think this will help us now.
Okay, sir.
So we were talking about the ML perspectives of cooperative spectrum sensing, considering the limitations of traditional or conventional spectrum sensing techniques. Researchers have attempted different machine learning algorithms, and it has somewhere started in last decade only. Uh, as you all are aware, I think the theme of this FDP was machine learning for signal processing. So you must have gone through the basics of machine learning, what exactly is machine learning, how it works, how the training and testing processes works for machine learning algorithms. So I'm not going more into detail about the basics of machine learning. We will straight away jump to the application part of machine learning as far as cooperative spectrum sensing is concerned. So the machine learning, obviously, it is capable of solving complex tasks. It is capable of learning, reasoning, and decision making. If you can recall the definition of machine learning by Michel, given in 1997, it says that the algorithms learn with experience, they have capability of solving some tasks, and of course the performance of these algorithms measured by the performance measure P uh, improves with the experience E in solving the tasks T. So the task T here is uh, classifying the uh, classifying whether the primary user is available or not. We can consider this spectrum sensing problem as a classification problem, and it's a two-class problem where this class represents PU, primary user active, or primary user inactive. Machine learning basically relies on the feature extractions, feature values from the sensing signals. There are different types of machine learning algorithms like supervised, unsupervised, and reinforcement learnings. We basically train the classifiers or the clustering algorithms to determine the spectrum states. So we will uh, this is the modified version of cooperative spectrum scenario. Earlier in the fusion center, we were applying some traditional or conventional spectrum sensing method. However, in the case of machine learning, we are having a complete machine learning framework available here. Definitely, we are going to have a training data set for training the machine learning model. Of course, a feature extraction step, which involves identifying discriminative features from the underlying data. And based on these features, we train the model. So whenever the model is trained and we receive new or unseen data by this model, this classifier is able to classify them into two of the classes. So basically, the task of instead of transmitting the complete sensing signal to the fusion center, these secondary users can extract the features at their individual nodes. In this way, they can save the energy as well as they can save the bandwidth while transmitting the complete sensing signal to the fusion center. So instead of sending the complete sensing signal, these secondary users can transmit the features extracted from those sensing signals. As far as the classification or different type of machine learning algorithms are concerned, we have supervised machine learning algorithms, unsupervised machine learning algorithm, and reinforcement learning. Some of the popular supervised learning algorithms are support vector machine, k nearest neighbor, naive Bayes.
Kulip sir, you got disconnected again. Dear participants, don't disconnect. Kulip sir will be joining soon after solving his issue at his end.
Uh, Hello, everyone. So Dr. Kuldeep will present from here. You can share, give us sharing content. Okay.
Yes, sir. We made it a presenter now.
Okay. Okay.
Yeah, I think the presentation is visible now.
Yes, sir, it is visible.
Okay, okay. So I'm sorry again with the participants. There was major glitch at my end, so I switched to another station. Now, so we're talking about different machine learning algorithms. There are major three categories of machine learning algorithms: supervised learning, unsupervised learning, and reinforcement learning. As far as supervised learning algorithms are concerned, the popular algorithms are support vector machine, k-nearest neighbor, naive Bayes, and all these algorithms are majorly used in the field of cooperative spectrum sensing by different researchers. Uh, in the case of unsupervised learning, the popular algorithms which are being used for cooperative spectrum sensing are k-mean clustering, PCA, Gaussian mixer model, fuzzy C-means, k-medoids. Some genetic algorithms are also used for cooperative spectrum sensing. There is very few evidences of reinforcement learning based cooperative spectrum sensing, where people have experimented with Markov decision process, multi-agent learning, and these algorithms. As I told you, the features plays a crucial role in the performance of any machine learning algorithm. So selecting an appropriate feature can help in improving the performance of these algorithms. Some of the popular features which are being experimented by machine learning algorithms for cooperative spectrum sensing are the energy vectors, covariance matrix, the power and SNR levels, some popular distances like Riemann distance, geodesic distance, and also some of the features based on the eigenvalues of the energy vector received at the fusion center. So these derived features are like the difference between the maximum and minimum eigenvalue. Also, the ratio of maximum eigenvalue to the trace of the matrix. Trace is basically the summation of the diagonal elements of a matrix. And another popular feature is the difference between maximum eigenvalue and the average energy. We will briefly review the mathematics behind these features. Like firstly, the energy of the sensing signals received at secondary user can be computed as the summation of all the sensing signals in a particular time frame. Suppose we are taking a time frame of suppose some millisecond, 5 or 10 milliseconds. So whatever signals received or signal samples received in this particular time frame are accumulated. So the ZS is the summation of square of all the sensing signals received in a particular time frame. So this ZS can be treated as a feature vector for training these machine learning algorithms. Secondly, the covariance matrix of sense signal at SU can be defined by this formula. This covariance matrix also can act as a feature for these machine learning algorithms. Third, the eigenvalues. The eigenvalues can be computed from the covariance matrix, which is shown here. There can be different eigenvalues: lambda 1, lambda 2, lambda 3, and lambda 4. Lambda min and lambda max are basically the maximum and the minimum eigenvalues. These two eigenvalues, the maximum and the minimum one, are extensively used in computing different derived features from these eigenvalues. So as we were talking about these derived features from eigenvalues, some of the popular methods of these derived features are difference between the maximum and the minimum eigenvalue. We term it as TDME, which is lambda max minus lambda min. Also, the ratio of maximum to minimum eigenvalue, that is also considered as one of the popular feature. Ratio of maximum to the trace of matrix, as I told you earlier, trace is basically the summation of all the diagonal elements of the covariance matrix. Difference between maximum eigenvalue and mean of eigenvalues. So as you can see in this formula, the MSE can be calculated as lambda max minus sum of all the number of eigenvalues given by total eigenvalues. And different combinations of these derived features can also be used, like the two-dimensional vector or the three-dimensional vector can be formulated with the combination of these TMME, TDME, TRMET, and TMS. These are some of the simulation results. Like, we have experimented with two popular clustering algorithms, k-mean clustering and Gaussian mixture model. And the input features were the RMET and the difference between minimum and the maximum eigenvalues. As you can clearly see, these clustering algorithms are able to form two major clusters, one denoted by the yellow color and another one denoted by the purple color. So, with the help of this machine learning, the clustering algorithms, we are able to identify which all samples belongs to the hypothesis H0 and which all samples belong to the hypothesis H1. So we can experiment with different classification algorithms as well, where we can input these different features which we have shown in the previous slides and apply different classification algorithms like support vector machine, decision tree, or KNN. Now comes the applicability of deep learning algorithms for cooperative spectrum sensing. Recently, the interest of the researchers has diverged towards the deep learning algorithms. There are some of the limitations in traditional machine learning algorithms which can be solved with the help of deep learning algorithms. One of the major limitation of machine learning is the handcrafted features or the manual feature extraction. We have to devise a methodology where every time we have to tune our algorithm whenever the type of feature changes. Whenever the input feature changes, the model needs to be retrained completely. Also, the features are not generic in nature. Some of the features might give good performance. However, we may have to experiment with different type of features. That is the major limitation of a machine learning algorithm. That is the reason people has shown their interest in deep learning, not only in the field of cooperative spectrum sensing, but in other domains as well. So why deep learning? I'm sure you must have studied about deep learning during this course, during this this workshop. So I'm not focusing majorly on the basics of deep learning, but I'll talk about deep learning from cooperative spectrum sensing perspective. So why deep learning? It helps in automatic feature extraction. We need not to have a dedicated step of extraction of features. It is the part of that model itself. It learns from the data. It learns extract hierarchical features. It extracts the features from the underlying data. It learns the useful representation of the input data. Deep learning works the way a human brain works. A human brain perceives the input data. As far as deep learning is concerned, the term deep means it is derived from the neural networks, and any deep neural network means having larger number of hidden layers. More the number of hidden layers, we are able to extract meaningful information from the input data. So that is the power of deep learning. These hidden layers helps in extracting features from the input data. The traditional neural network used to be a three-layer architecture where one input layer, one hidden layer, and one output layer. But with the advent of deep learning, we are able to process large amount of data and extract meaningful information out of the input data. It helps in finding discriminative features. Deep learning is more about learning the representation of the data, finding the patterns from the data. Whether it is audio data, whether it is visual data, whether it is text data. The most popular deep learning architecture is convolutional neural network, and which has been extensively used in the field of cooperative spectrum sensing as well. The interest of researchers in the field of deep learning gained somewhere in 2018 and 19, and people have started experimenting with convolutional neural network or LSTM based architectures for cooperative spectrum sensing. So as far as the architecture of a convolutional neural network is concerned, it consists of majorly 4 types of layers. One, the convolution layer, as the name itself suggests. There will be a convolution operation on the input data in this layer. Different type of filters are being applied on the input data, a matrix format data, and these filters or the kernels are able to extract low-level features. Then we have pooling layer. So this pooling basically reduces the size of the input data. Pooling squeezes down or reduces the dimension of the data. Next comes the rectified linear unit or the activation layer. This particular layer brings non-linearity into the system. Any practical system need to be non-linear in nature. So this particular layer, rectified linear unit, brings that non-linearity into this pipeline. And in the last, we have the fully connected layer, which is connected from all the nodes in the previous layer, and which helps to the classifier to take a decision on the output. So this was the first work which was reported for cooperative spectrum sensing based on convolutional neural network. This paper, Liu et al., applied convolutional neural network, and the input to this convolutional neural network was a covariance matrix. And they devised a test statistics. They developed a test statistics threshold and compared the output of this convolutional neural network with a computed test statistics. And if this is greater than this threshold, that means the primary user is active. Else, the primary user is inactive and the secondary user cannot access the spectrum. Then Chan et al. Recently proposed a STFT-based convolutional neural network method. Instead of covariance matrix, they experimented with the time frequency matrix. They computed the short-term Fourier transform of the sensing signal received at secondary user to exploit the time frequency domain information of the sensing signal received at secondary user. This particular convolutional neural network architecture had 2 convolution layer, 2 pooling layer, 2 fully connected layer, and a flattened layer. And finally, in the last, we have the softmax layer, which helps in classifying into 2 of the classes corresponding to the hypothesis H0 and H1. Then The authors experimented with convolutional neural network again to learn the activity pattern of the primary user. They argued that instead of taking the covariance matrix of the present time frame, we should also consider the historical covariance matrices. So basically, they experimented with two parallel structures of convolutional neural network, where one of the structure was considering the present sensing data. However, the second structure was considering a bigger matrix constituted by from the historical covariance matrix, and a collective decision was taken based on these two types of inputs. They argued that the sequential data also plays an important role in deciding the primary user activity. Instead of inputting the current sensing matrix, we should also consider the previous or historical sensing matrix of the secondary users. So they proved that considering the historical covariance matrix has shown promising results in comparison with the methods who are considering the present sensing data. Now, how do we measure the performance of these algorithms, these machine learning or deep learning algorithms? How do we say that this particular algorithm is better in comparison with the other one? So there are some of the popular performance matrices like classification accuracy, probability of detection, probability of false alarm, receiver operating characteristics, average throughput, energy efficiency. So these are some of the popular performance matrices which are being used to evaluate or compare the performance of these machine learning or deep learning algorithms. So the ROC curve is basically a plot between the probability of detection and probability of false alarm. So I think these are very popular terms, the probability of detection. Probability of detection, it gives us the like detecting the presence of a PU when the spectrum is actually occupied by the primary user. However, the probability of false alarm is defined as probability by a secondary user that declares the presence of PU when the spectrum is detected free. So this is the erroneous reporting. The probability of false alarm evaluates the false reporting. So these are crucial performance matrices which are being used for the evaluation of these algorithms. These are some of the simulation results which our research group has presented. On the left-hand side, we can say the ROC curve. It is the curve between probability of detection and probability of false alarm. And the area under curve tells you the performance. More the area under these curves, better the performance of the algorithm. So we have compared the performance of convolutional neural network with traditional artificial neural network and some of the machine learning algorithms like support vector machine, k-mean clustering. As you can see, the convolutional neural networks clearly outperformed other traditional machine learning algorithms by a heavy margin. Also, on the right-hand side, we have plotted a graph between probability of detection in terms of SNR. Here also, we can say that convolutional neural network gives better performance in comparison with other machine learning algorithms. So this majorly concludes my presentation. Some of the future research directions we can discuss, which can be of interest for the researchers here. One of the major challenge here is to assist the cognitive radio so that they can perform adaptive learning and decision making. How we can infuse some kind of intelligent algorithms in cognitive radios so that they can fulfill different type of requirements of next generation wireless networks. Other directions could be, nowadays these models, I mean, there are different dynamic changes in the wireless environment, like different channel conditions. As I gave you one of the examples where we were considering a practical scenario and antennas are experience different type of fading. So how can we make our model so robust that it can adapt any real-time changes in the wireless environment? Next, the mobility scenarios of the secondary users. How can we model that mobility of secondary users? That is also one of the challenging areas in this field. So with that, I would conclude here. These are some of the popular references which we have referred in our research. Recently, we have published a survey paper on machine learning for cooperative spectrum sensing and sharing. You can refer it for more details. So the floor is open for the questions. If you have any questions, please let me know. And once again, I'm really sorry for the inconvenience due to the breaks in between. Any queries, please?
Dear participants, you can write in the chat box, or else you can raise your hand so that we can unmute you for the queries. Mr. Devarakonda, you can ask the query. Sir, there is a query from Nikita Jain. How can we get public data sets to get started on this problem?
I think public data sets are not made available by the researchers. Usually people perform simulations for generating these data sets. So they simulate different type of channel conditions or wireless environment conditions, and they create their own data set. As far as my knowledge is concerned, no public data set is available for these research domains. And also people have experimented with actual cognitive radio network. They have placed the hardware in the field and then collected the data from that scenario. Any other question, please?
Devarakonda, you are unmuted. You can raise your query.
Yes, of course. some simulation tools can be used to create the data sets. I mean, of course, you have to simulate the environment. So some of the popular tools can be used to create these scenarios. Any other query? Reference to these tools, yes, I can share it on, please share email with me so that I can share, you can send an email to me. I can share the reference to these tools. As far as my research group is concerned, we simulate using programming. We simulate with the help of Python programming language. We simulate this environment by programming. We are not using any tool for simulating this wireless environment for cooperative spectrum sensing. Any other query? So it's quite easy to, one of the question is how to set probability of false alarm during simulation. So during simulations, you can use these probabilistic values while generating these type of data. So it's quite easy to, set the probability of false alarm while simulating these data. What are the possibilities of hardware implementation of CNN? Yes, one of the ways of implementing CNN on hardware is these edge computing devices, like the new age edge computing devices. You can implement convolutional neural networks on this. Nowadays, recent research areas, people are experimenting, implementing convolutional neural networks on FPGAs. So yes, research is going on in these directions. Please share your mail ID, sir. I'll request, I think it's kuldeep.ece. Let me write it here. .ac.in. You can check it in the chat box. I have shared my email ID here. All attendees. Any other query, please? We are running out of time. So if not, we can conclude here. Okay, so thank you. Thanks a lot for patience listening from my side. I thank you, all of you. I thank you, E&ICT, for giving me this opportunity.
Thank you, Kuldeep sir, for such a nice presentation and sessions. Now we are moving towards the last theoretical session of this day, lecture 21, Machine Learning for Smart Healthcare Systems. It will be covered by Dr. Amit Mahesh Joshi sir. Before we start, let us share his brief profile with you. Dr. Amit Mahesh Joshi sir completed his MTech and PhD from Sardar Vallabhbhai National Institute of Technology, Surat, in 2009 and 2015 respectively. He is currently an assistant professor at Malviya National Institute of Technology, Jaipur, since July 2013. His area of specialization is biomedical signal processing, smart healthcare, VLSI DSP systems, and embedded system design. He is a senior member of IEEE, member of IETE and member of IEEE. He has also published 90 plus research articles in excellent peer-reviewed international journals and conferences, and also has published 6 book chapters. He has a total of 699 Google Scholar citations, I-10 Index 22, H Index 14. He served as a reviewer of technical journals such as IEEE Transactions, IEEE Access, Spinger, Elsevier, and also served as technical program committee member for IEEE conferences. He has also received the honor of UGC Travel Fellowship, the award of SERB DST Travel Grant and CSIR Fellowship, and also attended well-known IEEE conferences, TenCon 16, TenCon 17, ISCAS 18, MENACOM 19, etc. across the world. He has served as session chair at various IEEE conferences like TenCon 2016, ICES 2018, ICES 2019, ICCIC 14. He has served as a track chair as ICCE 2021, publicity chair of ISVLSI 2021, and program vice chair of ISES 2021. He has served as mentor of IEEE Engineering in Medicine and Biology Society Student Mentorship Program 2021. He has supervised 4 PhD theses, 25 MTech dissertation, and 19 VTech projects in biomedical signal processing PLSI embedded systems. He is also the founder and director of startup Swarogyam Medical Devices Private Limited, which is presently incubates at MNIT Innovation and Incubation Center, Jaipur. Dr. Amit Mahesh Joshi, sir, welcome to this online joint faculty development program.
Thank you for such a nice introduction. The only thing is I'm not able to share the content. Can you just make
Please
me
check, sir, now.
presenter? I'm not sure.
Yes, sir.
Okay. Now it's. I believe that now my screen is. Yes, my screen is visible, I believe.
Yes, sir, it is visible now.
Yes. Okay. Thank you, all of you. Thank you for such a nice introduction. So today I will be discussing about the role of the machine learning in a smart healthcare application. Okay, now actually means we are talking about in the time when we are having the pandemic. Okay, and we are more care about our health than ever before. Now, role of an engineer in a basically health domain is equally important than a doctor. Okay, so to be honest, if currently if you are in some critical condition, then possibly you will look for a good hospital rather than search for doctor. Okay, and when I say a good hospital, then it is mainly associated with the technology or facility that is being provided, and where the role of the engineer is very critical. Okay, and the machine learning will definitely help to go for a smart healthcare system. So today we will discuss about what is the smart healthcare system. Then I will briefly talk about some of the application where our research group is working, and finally I will also present some of the challenges that we can have in adopting these solutions in our today life. So outline is I talk about the role of to see from the traditional health to smart health. We will trends of the smart healthcare. Then we will talk about the application and finally challenge. Now, what is the traditional healthcare system? Okay, so if somebody is admitted in a ICU, then you require a fully attention for that particular patient. Okay, that means you require a dedicated who will take care of that particular patient 24/7. Okay, sometimes maybe the delay in a treatment in a critical condition, in an absence of healthcare staff at that particular moment, it could lead to a loss of a life of a particular patient. Okay, now if I look at traditional healthcare system, then here there are multiple stakeholders are being involved. So ultimately, if means I will be diagnosed with some disease, then possibly I need to go to a laboratory, then I need to go for some test, and I need to again go to a doctor where I need to when he will observe my medical condition, and then he will prescribe me. Then I will go to a medical shop, and then I will take the medicine appropriately. So if you talk about that here, there are stakeholder in a healthcare domain. Okay, each are individually are playing their role very well. Okay, but what is the important that we want that in a smart healthcare, all these stakeholders will talk with each other. Okay, so currently in a traditional healthcare, there is reservation among the different stakeholders because of this decentralized system. So why smart healthcare is important? Okay, smart healthcare will provide a technology where we can have some smart center. Smart sensor will help you to capture the lots of data, which is from your physiological parameter. Now that actually help you in a treatment. Okay, as well as to monitor your health condition almost 24/7. Okay, where you do not require any dedicated support staff. Okay, so if the staff is absent and also able to capture the critical parameter of an ICU patient, and it could be observed by a doctor at a remotely location. Okay, by monitoring this situation, we can have a taking a preventive action, and as well as we can find out early diagnosis of a disease. Now, smart healthcare is actually continuous health monitoring as well as healthcare automation. It would apply closed loop solution. That means we are not only capturing the data. From those capturing the data, we will also take care of preventive action. It will also help to provide a drug delivery management at proper time. It will ultimately help in preventive healthcare system. Now, when I talk about the healthcare, then of course the role of ML is very important. So at the same time, we can't deny the role of a IoT. Okay, because IoT will play a role, transmit and analyze data. Okay, because we have a very good smart sensor, captures the data, but ultimately we need to process this data. Okay. To process that, transfer that data to a cloud where we can do some sort of processing. At the cloud, the learning will work. Okay, but for the transmitting the data, why is it? Probably the IoT will play a crucial role. Okay, so IoT role is very important when we want to transform the traditional health system to a smart healthcare system. For the patient and clinician, this application are playing a very important role when tracking and preventing a chronic disease. The chronic disease are a category where which actually occurs inside our body gradually. It not happens all of a sudden. Okay, like diabetes. Diabetes would occur inside your body gradually. Similarly, cancer is also. So if we get able to diagnose that particular disease early, then we can take a more preventive action or better preventive action for that. So at that time, the IoT will also play the equivalent role in ML. Now, whenever I use a IoT in a healthcare domain, okay, and if I look at the overall picture, then this picture is actually being considered as a healthcare cyber physical system. Okay, where you have some embedded software which will actually take care of your data processing part, and you have some embedded hardware like a smart sensor with data. Now I will talk about some of the we can utilize for a health. Talk about a smart healthcare. Health is a term which we popularly use for the smart health. Okay, so smart healthcare will cater the demand of connecting a patient and doctor remotely. Okay, and it is a very good option for a present condition where in a COVID, possibly we are now in the starting of the third wave. Okay, so now for our routine checkup, maybe means we want to avoid a contact with the any other person. So at that time also doctor would Okay. Is e-health. Okay. So use any of our healthcare document, vital information for delivering the healthcare information to health professor and health consumer through internet and telecommunication. Okay, of course, we need to have some protocol so that this particular facility can be adopted in real world application also. Telemedicine is also one of the popular way in which the telecommunication and information technology could be utilized to transmit the healthcare record at a distance. M-Health. So whenever I use a mobile phone in my healthcare domain, then you should term them as a health, M-Health. Okay. So where mobile phone can be used to collect the patient vital information. Okay. So there are some mobile app are there which actually help us to capture the data, how much you walk. Okay. What is your pulse rate? Okay. So these are the information could be captured with the mobile phone. Okay. And mobile phone we consider as a convenient way to reach each individual. Okay. So you can pass the information to each individual very easily through a mobile phone. So we can use the SMS services also to actually provide the vital information. Okay. One of the popular mobile health application known as a M-Hero, which was developed in a 2014 by UNICEF during the crisis of Ebola, which occurs in the African region. Okay. So at that time, in order to provide useful information to people, they are using the M-Hero application. Okay. Currently, during the COVID situation, we are also using one of the popular application we use as a Arogya Setu. Okay. So where maybe we can take the vaccination certificate and we can actually get all the data related to the COVID-19. So real-time monitoring of the patient, vital sign and direct provision to provide the point of care solution. That is also possible mobile health. Now, mobile health could be used to rapid collection and sharing the information through a mobile phone. As I said that currently we consider that around 60 to 70% of access of the mobile. Also, you can have send some public awareness message over a mobile phone. Medical alerts could be also sent through a mobile phone. E-prescription by a doctor could be also provided by a mobile phone. Telemonitoring to have a vital information of the patient can be also sent by a mobile phone to a clinician. Also, some of the laboratory now supporting a test result to a patient via SMS, or maybe you can log into the internet and where at home only you can get your lab reports. Connected health, which is very vital component of my smart healthcare system. Okay, here I want that all the stakeholders which are being involved in a healthcare sector will talk with each other. Okay, so at the first slide itself, I defined that currently in a traditional healthcare system, we have all in a decentralized manner. Now, in a connected health, they will be connected with each other. Okay, so in a 15 August address of 2020, our Honorable Prime Minister has announced that every Indian is now about to get the digital health ID. Okay, so that digital health ID would be a first step to go towards the smart healthcare or a connected health. Now, what will be the case that like your Aadhaar card, the digital health ID will be used for each and individual to track their medical history as well as their record. Okay, so what would be the case now that if I am going to a doctor, then doctor will provide a prescription, or maybe he will suggest some test, laboratory test, then he will enter those data against my digital health ID. Now, when I visit a particular laboratory, then I do not have to carry that prescription. Okay, against this health ID, whatever the test which is being prescribed by a doctor, that will be performed, as well as if doctor prescribes some of the medicine, then I can go to a medical shop without carrying any hard copy of that prescription. Against that digital health ID, whatever the vaccine is being prescribed by a doctor, that would be available to me. As well as another important thing is to claiming the medical insurance. Okay, currently what is the condition that if you are being admitted at a particular hospital, then you should be admitted for some duration of time. So then some of the person of the mediclaim insurance company would visit. He will assess your physical condition, and then your medical claim would be passed. However, with the connected health, as everything is being gathered at a cloud, and all the health professionals are providing the data, so maybe the physical visit for the mediclaim could be also avoided, where they can just observe this medical data, and from that they can just give you the mediclaim, whatever is being there. Now, such kind of connected health system is already in place in some of the European countries, and in America also there are few states which also have adopted this kind of solution. Hopefully, with the initiation of this providing digital health ID in India also, we could have a connected health system in our country very soon. Now, I will talk about some of the application where our research group is currently working. Okay, so one of the problem where we are currently working is a diabetes. Okay, now if we talk about the diabetes, then you will observe that diabetes is crisis of this particular century, where around 422 million people diabetic people around the world. And if we talk about the India, then it is around 77 million people are suffering from the diabetes. Now, if you are a diabetes patient, then for you, the measurement of blood glucose is very vital. Okay, actually, you should measure your blood glucose frequently, recurrently, in order to take the preventive action. According to that, if you fall under the category of diabetes, then you need to go for a strict diet control. Now, currently, there is no smart healthcare solution which is available for those diabetic people for have a better glucose management. We have worked towards that. Now, if we talk about the diabetes, then diabetes is actually root cause of so many diseases. Okay, you can have some eye disease, eye problem. You can have a hearing impairment. You can have some skin-related disease, kidney-related disease. It can damage your nerve system. Of course, the cardiovascular disease, which is also one of the prominent form of your heart attack. Okay, that also having a linkage with the diabetes. Now, if we talk about the current situation in COVID-19, then there are enough data are there which suggests that COVID-19 is more likely to affect the diabetic patient than the non-diabetic patient. Okay, so diabetes management is really important. And in addition to that, if we talk about the previous virus, which is H1N1, SARS, MERS, which occurs in 2002, 2009, 2014, at that time also, the virus is infecting morely for a diabetes community. Okay, so we require some sort of smart healthcare management system to help this large community where we have worked on. Okay, so when we talk about the diabetes, then there are few symptoms through which you can actually get the initial idea about the diabetes, where one can have a frequent urine excursion. You will find out constant hungerness and thirsty. You can have some sort of kidney disease. Even you can have some problem for the vision. Okay, now probability of the death with the diabetes is increased 50% more than a non-diabetic patient. Okay, and as I said that in India is also the capital of the diabetes. Okay, now if you look at the COVID-19, and COVID-19 also hit few countries very badly, like India, USA, China, Brazil, and if you look at them, then these are the top 4 countries which actually having the maximum diabetes patient. Okay, so diabetes management is very important. Now, when I talk about the diabetes, then diabetes is actually of 3 categories. Okay, the third category is a gestational, which occurs during the pregnancy of the woman. Okay, and that is a temporary diabetes. But if you will not take care is properly, then there is likely case that with the higher age, you can have either type 1 or type 2 diabetes. Okay, type 2 diabetes is where major of the people lies. Almost 80 to 90% of the diabetic people are having a type 2 diabetes. Okay. And type 1 diabetes is very less. Okay. Now, just to understand that what is a diabetes? Okay. So when you take any food intake, okay, from the food, the glucagon is being generated. Okay, so in our pancreas, there are two cells, alpha cell and beta cell. Alpha cell will generate the glucagon, which actually contribute towards your glucose, and beta cell is actually producing the insulin. Now, inside your body, the insulin and glucose balance is very important. Okay, in type 2 diabetes, what happens that your body is not able to generate enough insulin to neutralize your glucose. Now, glucose is not at all bad. Okay, just try to understand that, because whatever your daily activity that you want to perform, that you can perform because of the glucose also. So energy comes from the glucose, but the balance of this glucose value is very important. Okay, now if you just look at that in a normal healthy patient, the glucose value is ideally in the range of 80 to 150 mg per dl, and that also depends upon whether you have taken a meal or not. Okay, if your value goes beyond 150, then there is a problem. Okay, then you need to take care about your glucose management. In type 1 diabetes, actually your glucose value is higher and your body is not able to generate any insulin. Okay, so at that time they need to take an insulin injection. Okay, and possibly you will observe that if you are a diabetic patient, then you need to take a medicine before you are taking a meal. Okay, that is one of the exceptional cases. What is the reason? Because you want to take insulin priorly, so that after eating a meal, the insulin will neutralize your glucose value. Now, for a diabetic, the glucose measurement is very essential. Okay, and the glucose of your body will keep on changing at every minute. Okay, so whatever my current glucose value, if I look at after maybe 5-10 minutes, then glucose value may be totally different. Okay, so if you want to manage your glucose profile inside the body, then you need to adapt for a continuous glucose monitoring. That means I should be aware about my glucose value at every time. Okay, so ideally I should get an alarm or some sort of warning when my body is having an excessive amount of glucose, to just avoid the diabetes. Now, continuous glucose monitoring is very essential. Okay, continuous glucose monitoring would help you to measure a body glucose at every point throughout your day. Okay, and in order to do that, whatever the present technology are there, that is not supporting. Okay, so if I talk about the current situation, then in a current situation, if I want to measure my blood glucose, then either I can go to a laboratory where I can give my blood sample and I can get my blood glucose measurement value, or maybe I can use some sort of self-care measurement device like AccuCheck. Okay, where I can just use my fingertip, where I can prick the blood and I can measure the blood glucose. Now, in both the way, the blood pricking is required. Now, frequent blood pricking would definitely cause a trauma to some of the people. Okay, so for that, you need to think about that some of the technology which actually help us to measure the blood glucose non-invasively. Okay, with the non-invasively, possibly you can measure your body blood glucose frequently during the day. Now, apart from that, whenever you use such kind of invasive technology, whatever we are using currently, with that, it can measure a blood glucose at that point of time. That means when I prick up blood from my body, at that time only, what is my blood glucose value, that I can measure. But ideally, as I said, that the glucose value keep on changing during your activities in a day. You should be actually aware about your blood glucose at every point of time. Okay, so at that time, such technology will not help. So that's why we have developed the non-invasive glucose measurement technology, which actually help you to measure the blood glucose at every point of time. So this is just a comparison where your invasive technology is basically two type, when one can measure the capillary glucose and another can measure serum glucose. So when you go for a laboratory, and in a laboratory there is some method through which it can measure your serum glucose measurement. Okay. Now we have developed a non-invasive where through a fingertip only you can measure your blood glucose. So glucose, when I talk about it, glucose is combination of CH1O bond. Okay. Now we have used the optical method where we are using a light source and we are incidentting the light source on a finger, and at the receiver end we are actually measuring the intensity of that light. Now intensity at the receiver end would vary according to whatever the blood glucose which is being present inside your body. So for that we have done some experiment to which we have observed which actually the wavelength for my optical source will help me to measure the blood glucose. Okay, so for that we have done some experiment at our material research lab where we have used some spectrometer. What we have done that we have taken a glucose sample of 5G, 10G and 15G, and we have dissolved into a distilled water, and we have also considered a spectrum of the distilled water, and then we have observed that the glucose could be observed at which particular spectral wavelength. And to the experiment, we have judiciously selected that 940 and 1300 nanometer be an ideal, which actually help you to measure the blood glucose. So this is a process flow that we have developed to measure our glucose measurement device. So that we term as a iGlu, intelligent glucose measurement device. Okay. Now in this iGlu, which we consider as our initial version, iGlu 1, where we are calibrating the value with our reference blood glucose measurement value. We have used the FDA approved device AccuCheck, and through which we have calibrated our device. Okay. And ultimately through a machine learning, we are predicting our glucose value, and that we compare it with our standard glucose value, and we have got some very good result. This is actually the NI spectrometer result that we have done at our lab, where you just observe that the peak is being observed at 2 points, and this 2 wavelength we have used it for our non-invasive glucose measurement. So we have used a dual wave NI spectroscopy, where we have used the absorption and reflectance spectroscopy. That means once the light is incident and if the glucose particle is found, then that light could be absorbed by this glucose particle, or that could be a case that it could be reflected also. So this both the spectroscopy we have used. Okay, we have used a 3-channel where we have used the absorption and reflectance at the 940 nanometer and only absorption at 1300 nanometer. We have tried it out the reflectance spectroscopy at 1300 nanometer, but we have observed that it is not actually improving our value. So just to avoid that sensor, we have used only 3 sensor approach for our experimental setup. So ultimately our device will help as a self glucose measurement device, which actually help in a continuous monitoring, as well as we have integrated with the IoT. Okay, so that means whatever the blood glucose value that is being captured by our sensor, that will be stored for a cloud. So you can go for a long time observation. Okay, so that you can actually get the actual idea about the diabetes condition. So this is just our setup where you just observe the 3-channel data. So you just observe, this is our acquisition model that we have used, where you need to wear 3 sensor at your 3-finger prick, and through which the voltage value is being generated. That voltage value we are logged into a computer, and in our computer the machine learning model will help you to predict our glucose value. Another work that we have extended in the similar line is measuring the serum glucose. Okay, now if you want to manage your glycemic profile, that means your glucose insulin balance inside your body, then actually you should be aware about your serum glucose. Now whatever the self-monitoring devices are available, that actually measure the capillary glucose. When you go to a laboratory, then you will able to measure your serum glucose. So what they will do, that they will pick up the blood from your body and they will put in a specific temperature, okay, where the serum and plasma are being separated, and that serum part they will use to measure your blood glucose. Okay, so what we have done in our updated version of our non-invasive glucose measurement. We term them as a iGlu 2.0, where we have used for the calibration purpose the laboratory based value. Okay, so that now we have calibrated our value with the serum value which are being obtained from a laboratory, and through which we have observed our glucose value. And in fact, we have observed that our accuracy is increased 5% more. Previously, we are getting 85% of accuracy. Now we are actually able to measure a more precise glucose value of our body, which is around 90%. Now, for the experiment that we have used the different category of people, we have used a pre-diabetic, diabetic, and healthy people, and through which we have carried out our experiment. And as I said, that 90% of accuracy that we are getting. In order to validate our design, we have also gone through a Clark error grid analysis. Okay, so what this Clark grid error analysis will suggest you? So here on a y-axis, you have actually your estimated value. Okay, and here you have a reference value. Reference value always comes from the laboratory. Okay, or whatever the standard FDA device, and again, which whatever our device will predict the value that is going to be measured. If both the value match, then ultimately it will lies in a zone A. If your value is fall under the zone A, then you can consider that your device is clinically accurate. And whatever the sample that we have tested on our 97 subject, for that all the 97 subject falls under the zone A. That suggests that whatever the device that we have developed, that is clinically accurate. Okay, and it could be used for a practical purpose also. 1 minute. Okay, sorry. Possibly I am not able to. Okay. So now this is the comparison result with the other non-invasive work which is being done previously. So you just observe that we have actually done the experiment on human. Our device we are also claiming is very cheap, because for NIS spectroscopy we require a LED. Okay, and we require a sample acquisition module where you have a simple discrete component. Okay, and along with the Arduino board. So with that, we claim that our solution could be ready for around 80 to 85 $US, where whatever the other non-invasive devices which are also available, still they are not popular because they are not having they are having an accuracy issue, and they are actually in the market with the 300 to 400 $US. So our price is almost 1/5 of those devices, and still able to measure the blood glucose value at a 90% of the accuracy in a non-invasive manner. Now, apart from this, we have also developed a concept at the preliminary level that how it can help to the type 1 diabetes. As I already informed that for a type 1 diabetes, you need to actually go for an insulin drug delivery. Then they need to take the insulin injection for inside their body before taking a meal. Okay. So what we have done, that we have integrated with our insulin pump with this particular our non-invasive glucometer. What happens that we have developed one insulin secretion model which actually helps secrete insulin inside your body according to your present blood glucose value. Okay. Currently, what happens that the people used to take an insulin injection irrespective of whatever my current blood glucose value. Okay. What should be the ideally case that you should be aware about your present blood glucose value, and according to that you need to decide that what would be the appropriate insulin level which you need to inject inside your body. Okay, so our solution would definitely help, where the insulin dosage could be decided at the run time according to your present blood glucose value, and with that you can go for a better glycemic profile balance inside your body. Another work which we are working as a research group is a upper limb prosthetic control for an amputee. Okay, now you may be observing that there are so many amputee cases. Actually, in India annually, 15,000 people are actually losing their hand due to accident or maybe some another reason. Okay, now for that, actually we have developed a robotic arm, actually which would work according to your signal which is being generated by a brain, and you can perform your day-to-day activity. Okay, so what is the idea? That you can have some robotic arm, and this robotic arm will able to perform all your daily activity and the signal which is being supplied by your brain. Now the robotic arm control or movement of the robotic arm could be done with either through a EEG or maybe EMG. So EEG is a signal which we actually capture at the scalp of our head. Okay, and EMG actually a signal which we can actually collect at the muscles. Okay, now we have observed that whatever the EEG acquisition device, they are very sophisticated, and of course the cost is very large. Comparatively, EMG, where you require an electrode and some sort of basic knowledge through which you can actually acquire a EMG signal very easily. So with that reason only, we have used a EMG based prosthetic control device rather than EEG. Of course, there are few attempts where EEG based prosthetic control is also being done. Okay, but just for the ease of the acquisition and as well as for a more usability, we have used the EMG based upper limb prosthetic control device. So you can have some sort of robotic arm where you want to help those people who are not having a hand, but of course they can have a robotic arm, and that robotic arm activity could be controlled through a brain signal. So what will be the typical scenario? That basically from the signal which is being generated by a brain, that you want to capture those signals at your muscles, and from the muscle, whatever the signal is being generated, from that you need to extract important features. Okay, now feature extraction could be at the time domain or it could be at the frequency domain. We have actually gone through a time domain feature extraction method because of the obvious reason, because frequency domain will require additional frequency transformation. So actually there is a deadline also, that once the brain is capturing some signal or generating some signal, then you need to capture and you need to perform that activity in 150 millisecond to 300 millisecond duration. Okay, and obviously the time domain feature extraction method would help to achieve that deadline. So that's what we have adopted. We also done some feature reduction analysis. We prepare a feature matrix and then we classify our activities. So initially we have started with the 4 activities, and from that we have ended up to the 11 different activities which could be performed. And those activities like a daily activity, that suppose I want to open my hand, I want to close my hand, I need to actually grab something. So those kind of activity we have done, and those we have actually been tested on amputees also, and it is working very well. So this is a simple way that you can capture your signal at the scalp of your body, where through a muscle you can capture your EMG signal and you can perform the control activity. So of course, if you want to capture the EMG signal from the muscle, then there are 2 ways. One through a surface electrodes, one is a intramuscular electrodes. But intramuscular electrodes require to insert a needle inside your body. But of course, nowadays the more popular approach is you need to go for everything non-invasively. Okay, so you do not have to pinch anything inside the body. So through a surface electrode, we are able to capture the intention very accurately, and we are able to perform few activities. Okay, so this is just overall view. Our brain cortex will generate some signal, and that signal we need to capture at the muscles, and through a muscle we can get the intention of the user, and that we can supply to our robotic arm. So this is just overall prosthetic control. Myoelectric prosthetic is just EMG based prosthetic control. So through a muscles, through a surface electrode, you are capturing the intention, you are doing some sort of pre-processing. Then feature extraction, which is a very vital. Okay, that feature extraction is a very important step. Okay, so you need to choose the features cleverly, and according to that you need to identify a particular pattern, and that you need to supply for a robotic arm. Okay, now just to show you, I have also collected one demo is being captured at our laboratory. I'm just playing it. It is just a 2-minute demo, just to show you that where we have used a deep learning, okay, and through which we are able to control the robotic arm.
Hello, Amit sir.
Yes,
Okay, sir.
I am here only.
Okay, sir.
I hope this video is audible also.
Actually, sir, nothing is visible at our end.
Oh, sorry. Is it so? Okay.
Now it's visible, sir.
No. I think it should be visible. This particular demo, I am running one demo. Is it visible? No.
Not at our end, sir.
Okay, 1 minute. Let me check my sharing. Possibly I have share only screen. Maybe I will share my whole. 1 minute. Just sharing. Again, I am sharing. Okay. Desktop, maybe. Oh, sorry. Possibly I need to. Is it my screen is visible now?
Yes, sir. Your screen
Yes.
is visible.
Are you able to see this demo video?
No, sir, it is not visible. You have to share that particular application, sir.
Okay. I am actually trying to share it with the 1 minute. How actually I can share that particular application? Okay, means that. Now is it visible?
No, sir.
Okay. Now I'm not sure that why it is not. Again checking and sharing. Okay, other application next. 1 minute. Possibly maybe I can share it later on with the students. Maybe I can
Yes,
carry
sir.
on because already it is just a showing a video of 2 minutes where I have shown that how the robotic arm could be controlled with the means whatever the demo that we have created at our lab, but that could be I can share with the participants, no issue. Okay. So possibly I am sharing my screen again so that I hope now the PPTs are visible.
Yes, sir, it is visible.
Okay, okay. So just sorry for that. I would like to show the demo of few activity control in a real time, whatever the demo which we have prepared at our lab. But anyhow, I can share it with the participants. Okay. These are the results that actually being generated from our experiment where we have applied it for a database also. We have also actually able to apply our concept to amputees. So 4 amputees we have recruited for our experiment, and actually our uh, robotic arm is actually working very well on those amputees also. Another problem where we are actually currently working is a depression. Okay, depression is one of the major problem. Okay, currently in specifically this situation where people are losing their job and maybe they're losing their near one. So around 300 million people are suffering from a depression. Okay, and according to the National Mental Health Survey, that 50% of Indians are actually suffering from one of the mental disease, and depression is one of the major mental disease which is being observed around the world. Okay, so there are some products are also available which actually help you to measure the or to know the status of a particular person. So Apple has also developed the one watch where actually monitor your daily activity, and according to that means he will assess that whether you are a normal or you are having some abnormal activity. Another work which is being done for the stress level, okay, where people have actually tried it out with the 3 sensor, where you can have a one temperature sensor, you can have a one accelerometer to know your physical day-to-day activity, humidity sensor which actually help you to sweat analysis, and from this 3 sensor you are collecting those data, and through some machine learning technique you can able to get the decision whether that particular person is not stressed or stressed, and if it is being stressed, then what is the stress value of that particular person. That could be also done. We have also worked on a means depression detection through a deep learning model where we have used an EEG. Now for the depression you can use a different approach. Maybe somebody is using a computer vision based where image through an image or video you are trying to measure the depression. But we have observed that EEG is actually providing the best result among all. Okay, so through a EEG we have attempted the depression detection where we have used a hybrid model of CNN and LSTM to actually capture the temporal as well as the spatial domain information, and through which we are able to classify a depression where we are getting almost 99% of the accuracy for normal and depressed people bifurcation. Now another emerging technology that is coming in for a machine learning that I am just trying to go through it in the next 5 minutes. So intelligent diet control for actually your glucose insulin. Okay, so for a diabetes patient, as we discussed that they need to actually take care of the diet. Okay, now there is some application which actually help you in that particular course. Okay, so that is one of the application is intelligent diet control. So whenever you are taking some meal at that time, you can take a picture of that meal and you can upload into that application. So from that application, what it will do, it will identify a particular food object. Now inside the database, all the nutrition which is being supplied by that particular food item, that is being calculated, and it will tell you that what amount of nutrition that you are going to consume, and if you are a diabetic patient, then whether this kind of nutrition is good for your present health or not. And once you consume this particular food item, then what could be your next diet plan? Okay, so if I would eat something at my lunch, then what would be the ideal food item that I need to take it at my dinner to actually maintain my glycemic profile? So this kind of intelligent app is already being developed by few of the researchers. Of course, the telemedicine is a state-of-art technique where doctor and patient can meet with each other, where you can have some sort of teleconsultancy mode, or doctor will provide the tele prescription, then you can go for a medication and you can go for some preventive action. Role of the telemedicine is very important, where the social distancing norm is being placed. At that time also, doctors also would like to avoid meeting with the patient. So at that time, the telemedicine could be used. Robotics role is very crucial. Okay, even during the COVID-19 pandemic, you have observed that the robotic solution have been used to sanitize some of the places. Even for the food delivery also, they have used. Even for the sample collection for a COVID infected patient, the robotics has been used. Now it is being projected that in a hospitalization and tourism industry, the use of the robotics will be more and more in upcoming future. Now our acceptance on this kind of technology is also being increased. Like if somebody asks me to go for an online delivery of the lecture, or if somebody asks the participant to go for an online teaching, then maybe before 2 years we are not actually accepting those. Okay, but now with this pandemic, that we are now adopting such kind of technology. Okay, so robotic solution will be also in place. Okay, and specifically in the tourism industry and for the hospitalization management, where the robotics will play a crucial role for the cleaning and housekeeping purpose. Okay, so this could be the future. Even industry 4 is also very important. Okay, so where we can have a some sort of smart manufacturing. Now during the second wave, we have observed that there is a scarcity of the oxygen cylinder. Okay, and some of the medicine. So maybe with the industry 4 solution, we can actually cater those demand, where we can predict that at this particular time, the demand of this particular medicine or this particular medical resources will be higher. So according to that, we can boost our manufacturing. Of course, we can have some sort of smart transportation mechanism where these particular resources could be reached very easily to those people. Over here also, to develop such kind of intelligence in an industrial 4 solution, the role of the machine learning is very crucial. Now, we are actually more conscious about the diet. Okay, even you can just observe that now the food product actually being sold in by the advertisement of boosting the immunity. Okay, so we need to also take care of whatever the amount of the food that we are taking, whether that food is healthy or not, because it has been observed that there are some unadulterated food are being supplied in the market. Okay, so as a consumer, you need to be aware about whatever the food item that you are purchasing or either you are consuming, whether it is having a good nutrition value or not. Okay, so there are some intelligent technique through which actually you can measure your pH level of the food. Okay, because if your pH level is higher than 4.6, then the bacterial growth inside the food is more likely to occur. So you can measure the pH level, and according to that, you can take a decision whether this kind of food you can take it at this particular moment or not, or whether this food is a healthy food or unhealthy food. So that for that also, the total food supply chain management at every individual stage, the decision could be taken very wisely with the help of some machine learning mechanism. Now, in 5 minutes, I will talk about the different challenges which are there in adopting such solution in our day-to-day life. So, of course, we are talking about a smart healthcare where we want to adopt e-healthcare, m-healthcare solution with the help of the IoT. But of course, the privacy and security is utmost important. Okay, we are talking about the health information, and according to this health record, we are taking an important decision. Now, the privacy and security of those data is very important. Okay, specifically in this present world where we have observed so many cyber crime event. Okay, so ultimately the privacy has to be taken care. Of course, you need to take the privacy of the medical devices. Okay, so we need to think about the robust mechanism for a hardware, providing the hardware security of these devices. Of course, whatever the data which is being stored at the cloud, that has to be secure enough. Okay, data integrity of this particular medical information is also important. Apart from that, the access control and authentication of monitoring this record is very important, because we want that whatever the data which is being captured by a patient and which is being stored at a cloud, the data could be accessed by only authentication purpose person. That means maybe a medical staff or a doctor. Okay, it should not be open for all other community. The power management is also very important, because we want that smart sensor which are being placed, it should capture the data throughout the day. Okay, but of course they will be variable device, they will be operated through a battery. So at that time, the battery management is very crucial, and there are lots of work has to be done so that these variable devices could help us to capture the data for so many days without charging mechanism. Of course, the interoperability is very important. Okay, so that means there the IoT, or when I consider medical devices in a IoT, then it would be a heterogeneous device. Okay, where some particular stakeholder are using, let's say, a Apple device, somebody is using some Samsung device. So there has to be seamless connection among those devices. Okay, so interoperability is also very important in in order to adopt such kind of solution in our day-to-day life. So finally, the ICT and IoT along with the machine learning would play a very crucial role to shifting from a traditional healthcare to a smart healthcare system, where we consider as a secure health cyber physical system. Of course, the intelligent algorithm along with the machine learning will provide a major impact in our day-to-day life, and lots of research are going on where it would allow us in near future to adopt such kind of technological solution in our day-to-day life. Of course, there are few challenges that we need to address, like privacy and security, before we can adopt it in our daily life. So with that, I am ending up our session. Sorry for taking, I think, 15-20 minutes more. I know that at 1 o'clock you have a lunch break, but maybe we can have a quick question from you. Maybe I can also check it from the chat box. If you have any question, maybe you can write it down at your chat box.
Sir, there are no questions in the chat box till now.
Okay.
Requesting participants to raise their queries in the chat box.
It seems that participants are also in a hurry to take a lunch. I believe that your next session is starting at 1:30. Okay. So of course, means we can take a few questions right now. Or if you have any question regarding anything regarding the whatever, I am just mentioning my email ID at a chat box. You can reach me at any point of time. We can discuss at offline also. Do this kind of research require hardware setup, or it can be done via public data set? Okay, so of course we have used the public data set for most of our research. Okay, for the diabetes also there are PIMA data set which are available. Okay, even we are also planning to whatever the data that we have gathered at our place, make it public. Okay, so this kind of data set are available publicly. Okay, but what is the important thing, to be honest? Okay, if you want to adopt such solution in your day-to-day life, okay, so at that time you need to actually test your algorithm on real world example, real subject. Okay, because most of the time, even we have observed also, the result will be very good when you operate on your data set. Okay, but when actually you apply those algorithms in your real subject, then maybe the scenario would be different. Okay, so data sets are available for all our work what we have done till now. But of course, then we have tested those algorithm in real subject also. And whatever the result that I have shown it for specifically for the diabetes, that those are for the real subject, not for the database. Okay. For the smart healthcare system, FPGA, yes, definitely role of the FPGA could be crucial, specifically when we want to run a machine learning algorithm. Okay, so possibly means in a previous lecture, the Kuldeep sir has defined some of the deep learning algorithm. Okay, now if you want to run such deep learning algorithm where you do not want to go for a manual feature extraction, where the feature extraction will be done by itself. So at that time, these are very complex algorithm and it is also time consuming. So for that, you can think about running those deep learning algorithm on FPGA so that you can get the result in quick time. Okay. Of course, there are some solution through a GPU also you can run it, but possibly the FPGA could be the another good alternative where you can think about the running your deep learning algorithm. Okay, for the data analysis part, for the machine learning part, definitely the FPGA is one of the candidate. Any recent example of security in IoT healthcare system? Okay. So actually we are only working or even for our iGlue, as actually I pointed out that we are actually running a complete whole closed loop system where the data is coming from the non-invasive glucose measurement and the data is being stored at the cloud, and from those reading the insulin secretion is being happening. Okay, so at that time we are actually thinking about the hardware security solution, means the device actually through which we are storing the data at a cloud, because the decision we are taking at a cloud. Okay, so we need to ensure that whatever the data which is available at the cloud, that is from the authenticated glucometer. So for that hardware security solution we have developed. Okay, so you can just search out our few papers that where we have actually talked about the hardware security solution for a glucometer as well as the insulin pump. For that we have actually worked on the physical unclonable function, that PUF. So PUF will actually help you to find out the every hardware signature, like our fingerprint. So every hardware can also have some specific fingerprint. So for that PUF based initial solution that we have developed, so that also you can do it. Okay, there are some other papers also where people are actually thinking about that how you can have a proper data integrity. What could be the good encryption algorithm through which we can ensure that that data is being intact at the cloud server. So those work are being done. Still, we are in a very early phase, as I said, that in adopting a smart healthcare technology. But definitely with the research which are currently going on, through which in a near future, definitely we would be able to adapt such solution in our day-to-day life. So means if you want still some paper, then I can share with you, Santosh. Definitely I can help you for whatever the material that I have, that I can provide it to you. Okay. And some of the paper that we have worked, oh, that also I can share with you, where we are extensively working on a security. Yes, any further doubt? Okay. So then if there is no further doubt, then thank you Electronics ICT Academy, specifically Guwahati, for providing me the opportunity to interact with all of you. I hope you have enjoyed this session. And if you have any further question, then as I said that we can discuss it offline. You can mail me at any point of time. I have already shared my email ID at chat box. Okay, thank you.
Thank you, Amit sir, for such a nice session. Now, dear participants, we would go for a lunch break and we will again rejoin at 2 p.m. sharp. Please be on time. We will start from 2 p.m.
Okay, thank you. Have a nice day, all of you. Thank you.
Dear participants, we have shared the feedback link here. You can see in your chat box. So all are requested to fill the feedback form.
Hello. Hello. Hello, am I audible? Okay, so sorry about the delay. I'm yeah. So yes. So now we are going to start the session on machine learning applications for wireless communication. Okay. So yesterday, I hope I made some presentations about some new reinforcement learning algorithms in wireless setting. I hope you have been able to get some new insights regarding that. So today first we are going to revisit those concepts again, so that maybe you guys have some questions. Uh, so uh, so we will just revisit those things. If you have any questions, feel free to ask. After that, we will move on to the hands-on related to that. Okay. So let me share the slides. Is my slides visible?
Yes, sir, it is visible.
Okay. Okay, so I will go. So in the introductory part, there was basically I talked about that machine learning can find its application in many future 5G use cases such as cognitive radio, massive MIMO, device-to-device communication, and energy harvesting. Okay. So also we choose an example of heterogeneous network as the use case. So this was the block diagram, and we show that this is our area of interest, where it's like machine learning algorithms can be useful, uh, where depending on the observation, that means it could be data, some data, some previous data which we have seen, and based on that we want to modify our strategy, or it can be some data from the like on the fly we are observing. So by now I think you have an good feeling about how reinforcement learning is different from other two types of learning. So this block diagram is generic enough to capture everything, because uh, in uh, in in supervised learning setting, these observations will come in the beginning, and depending on that you are building the model, your strategy will depend on that. But in the in the reinforcement learning setting, it's like on the fly. So you choose some actions, compute the utility, and then you come up with a strategy, and then based on the observation it is fed back to the system, and this process continues. So in reinforcement learning, you basically do not need a data in the beginning. You can start with zero data, and then as time progresses you are gathering the data on the fly, and your learning is also happening in a continuous fashion. Okay. So yeah, so these are the possible applications we discussed yesterday, that supervised, unsupervised, and reinforcement has their applications in this kind of problems, such as resource allocation, energy harvesting, spectrum sensing, cognitive radio, and so on. And then we went for this reinforcement learning algorithm for radio access technology selection in LTE Wi-Fi heterogeneous network. So this was the model uh, where there is a base station with a wider coverage area, and inside the base station there is a Wi-Fi access point with a smaller coverage area, and then we described that uh, the optimal rat selection strategy, optimal rat selection problem can be formulated as a constrained MDP problem, but it suffers from the Karpov modeling. So Karpov modeling is basically the knowledge of uh, transition probabilities are required to find the optimal strategy using Bellman equation. Okay. So to address this fact, people are using Q learning, which can um, remove the curse of modeling, and it can work without the knowledge of the transition probabilities. But there are few issues such as slow convergence. Okay, so can anyone answer what is the reason behind slow convergence? I mean, what is the phenomena that leads to the slow convergence? Maybe you can answer in the chat that why the convergence is slower. What is the mechanism due to which the convergence becomes slower? We have discussed this, so I just need a feedback that okay, you that whether you have understood this concept. So can anyone one of you answer in chat what is the reason behind slow convergence? I got one answer. Any other answer? Okay, so 2-3 answers I have got. One answer is Narasimhan is saying Q learning has to check Q table to pick up the largest Q value. That's a drawback associated with Q learning, but it is not related to slow convergence. Okay, that is related to the second point, that is computational complexity, because every time it has to check the Q table to pick up the largest Q value. So that means if there are A actions, basically you need to check A entries. Okay, so therefore computational complexity reduces. Increases. So what Narasimhan has said is a good point, but that's not the reason behind slow convergence. That's the reason behind high computational complexity. Nitika says as it randomly does exploration for policy decision. Very good. This is the reason actually that the exploration is associated with it. And if the actions are well separated, what I mean is if one action is, one action is prominently better than the other action, then maybe high amount of exploration basically kills the convergence behavior. So this answer is correct. Okay. So so now what we want to do is we want to address this to fact that slow convergence, high space and computational complexity, how can we get rid of these factors? Because in large problems, as the in network becomes larger, so these issues will be even more problematic. Slow convergence is a big issue because so for example, you are dealing with a telecommunication wireless system, okay? And what happens is that generally these decisions are chosen whenever there is an arrival or departure or changes in the channel condition and so on. Okay, so if now for example you are running an algorithm and that takes 1,000 iterations for converging to a good value, okay, then you are basically losing 1,000 time steps in the beginning, so 1,000 arrival or departures. So for example, in your base station near your home, there has to be 1,000 calls in the beginning for the policy to go to a good perform to give a good performance. Now, but 1,000 arrivals or departure means it might take a lot of time. By the time it learns the correct behavior, it may happen that your policy, that your arrival rate itself has changed. Okay, so that's a big issue. That by the time you learn the correct behavior, your parameters has changed. So therefore, convergence has to be faster. And obviously, computational complexity is another issue, which is like you need to use good machinery in the base station side. Okay, and if your algorithm is running in the base station, then that is still manageable because your base station is like some it has been installed by the operators, right? So they can put some good processor there. But if your algorithm is for example implemented in your mobile phone, and your mobile phone has to go through many processing, then that is not good because your mobile phone has limited battery consumption, limited limited capability and so on. So therefore that's a big issue. You know, nowadays there are advanced algorithms for Wi-Fi selection also. Previously you might have seen that when your mobile phone has, if you switch on your Wi-Fi, then it is like always searching for Wi-Fi continuously in a periodic fashion. So even if you are not nearby your Wi-Fi access point, then also it will keep searching, and therefore the battery drainage is too much. I mean, it will continuously like try to send some beacons, try to sense some beacon signal sent by the Wi-Fi access points. Okay, so nowadays you will see that sometimes you switch on your Wi-Fi, and when you go out of the Wi-Fi range, your Wi-Fi is automatically switched off. Have you seen this phenomena in your mobile phone nowadays? So I have a Redmi mobile phone. So I have seen this now, that whenever, for example, I'm using Wi-Fi, and whenever I'm out of Wi-Fi coverage, it automatically shuts down my Wi-Fi. So that's has been, these are the some of the new techniques that has been implemented in mobile phones also to like reduce the power consumption. So power consumption is a big issue. In internationally and nationally, people are looking for green solutions. You may have heard about this term, green solutions. So power consumption is one of the biggest issue mobile communication system. Okay. So coming back to RL algorithms, uh, this threshold structure is very common in many applications. You will see that this threshold structure is very common. For example, you, if you remember, in the day one I have shown you one slide where I have presented one telecommunication example, that users are coming, and then they are allocating resources, or they are getting blocked. So there also the optimal policy is of threshold structure. It has threshold structure. So here also we have been able to prove that there exists a threshold structure. So but now if you know that there exists a threshold structure, then what you need to know is the what is the value of the threshold. Okay, so up to the threshold you are following one policy, and after that you are following another policy. So you need to know the value of the threshold, but the value of the threshold will depend on the transition probabilities, which we do not know. Threshold without knowing the transition probabilities. So this approach basically reduces the computation a lot, and also it leads to faster convergence. So this was the overall point that I wanted to make. Okay, so I'll not go into the details. I hope you are remembering these things: state space and decision epochs. So state space is, yes, is a three-dimensional Markov chain. Okay, so IJK. I is the number of voice users, J is the number of data users in LTE, and K is the number of data users in Wi-Fi. Okay, so this was the state space, and action space were actions consisting of accepting users, offloading, and blocking. Okay, so these were the actions available. So yeah. So any of you have heard about the term 3GPP, third generation partnership project? Any of you heard about this this terminology, third generation partnership project? If yes, please respond. Okay. Okay. So yes, it's used in 5G. So yeah, so 3GPP is basically a standardization body. Okay, so which makes standardization for mobile communication systems. Okay. So so 3GPP, if you see, these are maybe interesting research areas for you as well. Because ultimately when we look for uh, ML applications in wireless, it is also required to find out appropriate use cases where ML can be useful. So so there are two aspects. One is you need to learn about ML concepts theoretically, and also you have to look for use cases which are relevant. Otherwise, if you blindly apply ML algorithms to problems, then that will not be of much interest to the research community. Okay, so you have to choose a good problem, good area where which is of practical importance. Okay, so 3GPP actually they drive the standardization for next generation wireless communication systems. Okay, so there was something called LTE Wi-Fi offloading. So when the standardization of 3GPP was going on in release 12, okay, release 12 of 3GPP, they have proposed this LTE Wi-Fi offloading, where users can be offloaded, users can be moved from LTE to Wi-Fi and Wi-Fi to LTE. Okay, so so this was the motivation. Okay, so when I formulated this problem using ML, so you see that there is an action that data offload to a RAT, except in LTE with data offload to Wi-Fi. So these things you have to make the connection that okay, offloading is something which is driven by the communication people, and then this thing I can model using MDP, and this should be one of my actions in MDP. So this is the thinking process in which you should proceed to make applications of ML in wireless standards. Okay, so this is my action space, and then I wanted to maximize the total system throughput, which is my reward, is total system throughput, and I want to maximize the average reward subject to a constraint on the cost. Cost is 1 when there is a blocking of voice users. Why is this considered? Because if you remember that we have told that when you want to maximize the total system throughput, then basically the voice users are blocked, because voice users have typically have less data rate. Okay, so so we want to ensure that total throughput of the users are also maintained, and also voice users, not many voice users are blocked. Okay, so another question to participants: do you know what is best effort traffic? How it is different from guaranteed bitrate traffic? Do you know the definition and the difference between guaranteed bitrate service and best effort service? Okay, so maybe I'll just explain it. So best effort service is basically if you look at Wi-Fi, okay, Wi-Fi is a best effort service because it does not give you any guarantee on the throughput. Typically, the throughput you obtain is good, but sometimes you will see that sometimes your Wi-Fi fail miserably. Like sometimes you are getting very good throughput, sometimes you are getting no throughput at all, no data rate. Sometimes your Wi-Fi is like not giving good throughput, and sometimes it is giving very good throughput, because there is no guarantee. Okay, so there is no guaranteed quality of service. Okay, so that's why Wi-Fi provides a best effort service. But on the contrary, cellular communications like LTE, 5G, these are designed to provide you best effort, provide you guaranteed bit rate. So for example, in the voice call, the data rate is very small, but it is guaranteed bit rate. You will definitely, you have the data rate that will be given to you is definitely has to be some number. Okay, so therefore it is known as guaranteed bitrate traffic. So yeah, so for voice users there is some guarantee in the blocking probability as well. Okay, so if you see the 3GPP standardization specifications, you will see that there are some numbers like for voice user the data rate has to be this much, the latency has to be this much, and the blocking probability has to be this much from operator's perspective. Okay. So now, since there is a blocking probability requirement for voice users, therefore I included this as a constraint in that problem. Okay. So these are the things that you have to keep in mind while formulating problems related to your for formulating problems, that each and every functions that you are introducing, that has to be there has to be some justification that why you are using these functions. Okay, so I am saying all this because there were many questions in the previous sessions that how I should formulate or how I can apply q learning to the problem. So these are the things you need to take into account, that whatever functions you are choosing, whatever your objective function is, those has some meaning, those has some from communication perspective, those has some significance. It's not like randomly chosen for the sake of a problem. Okay, so yeah, these are some of the things that we need to keep in mind. Okay. Okay, so moving on, uh, this is the problem formulation. We wanted to maximize the average expected reward subject to the constraint on the average expected cost. And there was a CMDP formulation, and you can find the optimal policy using combination of value iteration and gradient descent. But it suffers from the curse of modeling because it requires the knowledge of the arrival processes. Okay, so this is the structure of the optimal policy that we obtained. So this is for data users. There is a threshold up to which the data users are served using Wi-Fi, and then they are served using LTE. Okay, so this also makes sense mm, because this also is very intuitive, right? Because for data users, for example, if you are using 802.11g, okay, 802.11g is a standardization for Wi-Fi access points. Okay, so for cellular, 3GPP is the standardization body. For Wi-Fi, the standardization body is IEEE. Okay, so IEEE 802.11 is the standardization series that are meant for Wi-Fi. Okay, so for whatever Wi-Fi you have in your home, those are compliant to these standards. Okay, so 802.11g is such a standard. Okay, so 802.11g, if you the line rate is 54 mbps, 54 mbps. So if there is only one user, typically it will get something around, it's like half of it, so it will get something around 25-26 mbps. Okay, but if you are now two users, then the total of these two will become less than 25. So for example, both of them will get something around 11.5. So 11.5 multiplied by 2 is 23, which is less than 25. So that's how the throughput in the Wi-Fi degrades. Okay, so in Wi-Fi, if you are a single user, you will get a good throughput. If you are two users, then the total throughput by two users will be less than that you are obtaining as a single. Basically, it's not like total throughput is constant. Total throughput is decaying with time. Okay, with with the load. So that's why if many people are there in a room, it is not a good idea to connect every one of them in Wi-Fi. The performance of everyone goes down. So therefore, there should be some threshold till which you are associating them Wi-Fi, and after that you go to LTE. Okay, uh, so that's the best policy for data users. Okay, so I will give you a reference for this modeling, which might be very useful for you. Just a second. So I have pasted the name of a paper in the chat. Okay, so this paper is basically the first paper which could derive the formula that how you will get what is the formula for a throughput of per user throughput in Wi-Fi as a function of the number of users and other parameters. So this was the first paper which derive it using some Markov chain based modeling. So this is a very useful paper if you plan to work on Wi-Fi or Wi-Fi based system or heterogeneous network where many systems are there. This is a very useful reference, and the model given here, the throughput model that is given here exactly matches. I mean, it's like very closely matches the practical performance of Wi-Fi systems. So if you want to work on Wi-Fi based system, this is a very good reference. Okay, yeah. Okay, so moving on. Q-learning, as we already discussed, I'm not going to discuss it again. There are many issues such as slow convergence, computation, and storage complexity. So therefore, we go for the post-decision state framework. In the post-decision state framework, there is a state, and the decisions are chosen. So based on the decisions, there are imaginary state called post-decision state. Okay, so because this is after the decision is made, that's why it is called post-decision state. Because in a typical state, what happens is that the decision is first made, and then the event, which is the arrival or departure, happens. Okay, because of this factor, there is a max. There is this max thing which is coming outside, and because of which it becomes non-linear. The system becomes non-linear. And now what happens is in the PDS framework, the max is inside and the probabilities are outside. So since it is outside, it can be replaced by averaging over time, and that leads us to the post-decision state learning algorithm. Yeah, where we update the value function in the faster time scale and in the Lagrange multiplier to accommodate the constraint that is updated in a slower time scale. Okay. So so the faster time scale and slower time scale, these things are again motivated by a paradigm which is known as stochastic approximation. So if anyone is interested in advanced RL techniques, stochastic approximation serves as a very fundamental in analyzing these algorithms. Okay, so I can share a reference for that to you, so that if you are interested in knowing what is this faster time scale, slower time scale thing, you can read it further. I will share the reference in chat. So yeah, so I have sent a book name. Okay, so this book is a very good reference for stochastic approximation. It is very this stochastic approximation framework is very useful in analysis of this convergence behavior of these algorithms, and because when you need to prove, right, whatever algorithm you propose, you need to prove also that these algorithms are converging to the optimal strategy. Okay, so for these proofs and other things, this paper, this book is very useful. If you want, you can try to find this book. Okay. So any questions till now? If you have any questions, please ask in the chat. Okay. If there is no other question, then I'll move to the other thing that we discussed yesterday. That was the key idea was reducing the computational complexity, because the maximization operation is very problematic. Okay. Because it is like it is computationally very expensive. So what we do is we fix a policy, because if we know that my optimal policy is threshold in nature, then therefore I can fix a policy for a given threshold vector and then evaluate the policy. Okay. So if I draw a diagram, it is like this. So it is like, you know that so this is, for example, this is 0 and this is 10. Okay. So you know that your policy is threshold, so it is like this. So up to 0 to say x, 0 to 5 say, you are following some policy, and thereafter you are following another policy, but this value is not known to you. So okay, so what you do is you fix a policy for a given threshold vector. So you basically say you initialize here. Okay, you initialize here. Okay, then so now this is a threshold policy. You 0 to this point, you are following one policy, and from this point to this point onwards, you are following another policy. So for the given value of this, you are computing the gradient. Okay, gradient of the system metric. System metric is my average reward. Okay, now after calculating the gradient, you see the what is the direction of the gradient. So if you are here and then you are computing the gradient, you will see that your gradient descent is taking you towards this. Okay, so finally it might happen that you are crossing this point and you are here then. Okay, and after some time again, the gradient descent, if you perform, you will see the gradient is pushing you in this direction, and finally after some oscillation, finally you will converge to the correct point here. Okay, so that's the idea, that you are following certain gradient at every point, and at this point the gradient will be 0, because this is the global like maxima. Okay, so it's like this. So whenever you are here, it will push you towards this direction. Okay, and whenever you are here, it will push you in this direction, and then finally you will land up here, because here your performance is best, because this is the optimal one, right? So this kind of things are being done here. Okay. So I am not going into the details of maths. I think that's the basic idea I wanted to convey. So this is my policy gradient algorithm, and this is the policy improvement. This is nothing but gradient descent. Okay, so this is the gradient descent routine, and this is my policy gradient. You see that there are these terms: transition probability gradient, and then reward gradient, which are which we need to obtain. Okay, but problem is obtaining these things are difficult, because I know my state space is discrete. Okay, so it is defined at discrete points. Okay, so now what we have to do is we make a continuous approximation using a sigmoid function, and then I will be able to calculate a derivative and then make the scheme work. So I am not going to the detail of this, because this maths equations might be confusing, but the basic idea is a gradient based approach using threshold as a parameter. Okay, so the key advantages are reduction in computational complexity. There is no maximization operation now. Here, I think there was a question yesterday by Abhiranjan that why there is no max operation here. Because now I think the answer is for a given value of threshold, your policy is uniquely determined. You need not do a maximization. You just need to find the threshold, which is being done by these lines. So these lines are basically finding the correct value of threshold, and this is the policy evaluation. Okay. So yeah, so now it's like faster convergence because the policy space is smaller, and the complexity, storage and computation both are reduced. Okay. Yeah, so some key results: storage complexity, computational complexity, and some graph which shows that the convergence is faster. So if you see in the x-axis, this is number of iterations. So the number of iterations is nothing but like the arrivals or departures of the users. So whenever there is arrival or departure, then we are changing the parameters. Okay. So this is how it operates. Computational complexity is reduced, and storage complexity is reduced. Okay, I think so. That's it from my side for the presentation for the theory part. If you have questions, ask me, because after this we will move on to the code. I will try to explain the code which leads to this plot, and we will see how RL algorithms should be coded, and some guidelines regarding the coding. Okay, that I will move on to this. But before that, I will take some questions. If there are some doubts, any kind of doubts, please feel free to ask. Okay. Yeah, please. I will be taking some questions now. You can post it in chat or you can ask directly. Okay, I think there are no questions. So maybe we can take a small break so that I open up the code, my GitHub account by then. Okay, so we can take some 5 minutes break and we can start at somewhere around 2:50. Okay. Okay, so one question: can you guide us how to understand the complex mathematics in papers? Okay. Yeah, that's a good question. So thing is, reinforcement learning, uh, these concepts, actually you should have a fundamental understanding regarding the basics. Okay, that is necessary. Then it will be able to understand the mathematics well. And I think therefore some basic introductory reinforcement learning lectures, if you attend, because I have tried to give you some flavor of Q learning, and also I have pointed you towards one book by Sarton and Barto. This book is not, I mean, this book is basically good for people who are entering the reinforcement learning world. So yeah, some concepts, if you think this mathematics may look scary, but thing is underlying concepts are not that scary. Okay, so the underlying concepts are like very intuitive. If you correctly understand the intuitions, I think then you will be better appreciate these concepts. Okay, so obviously some amount of theory knowledge is required to better appreciate these things, but Yeah, so I would suggest you to start with that book if you are interested, Certain and Barto. That book is a very good introductory book for reinforcement learning concepts. Okay, then gradually you will be able to cope up, and gradually you will be able to understand these concepts well. I would, okay, okay, thank you. Okay, so maybe we'll take a break now. If you have further questions, feel free to post in chat. Okay, so there is another, suggest some more references on CAC. By CAC, do you mean Amol? By CAC, do you mean call admission control? Okay. Okay, let me give you some references on that. So I'm just pasting some references for call admission control. I think I'm going to paste the last one. Yeah, so these are some of the good references for call admission control. It's a very classical problem. If you see that all of many of the papers are fairly old. 1998 also is there. Okay, so the last reference which I pasted is it's a technical report, monotonicity in Markov reward and decision theory. Okay, so I was talking about threshold structure. Okay, so this threshold structure, it's like you can find how to prove this threshold structure in general. This book is a guideline. This book provides you guideline, and then how to prove these threshold structures in a normal in a usual Markov decision process problem. Okay, so yeah, I think these are some of the good references. So the person, this Gerkul, he is also a very famous queuing theorist who has been working in this area for quite long time. Okay, any other Any other queries? Okay, so maybe I will take a break now before we start going to the code. Maybe if I make connections of the code to the theory, then maybe you will also understand it better. So we'll take a break and then maybe we can meet at we can again start at 3. Okay, so it is 2:50 now. We'll take a small break. We'll start at 3. Okay. Okay, so we'll start at 3. So welcome back, everyone. Am I audible?
Yes, sir, you're audible.
Okay. Okay. So I will share a link now where we will try to see the codes that we have been talking about for the last few days. So okay, so this is a GitHub link for the codes for the algorithms that we are talking. It's especially the Q learning and the structure aware learning. We will first open the structure aware learning and see what is happening. So this is the link for structure aware learning. So any of you are familiar with Network Simulator 3, NS3? Little bit. Okay, Yasha has responded. Yes, little bit. So if you are if you want to work in, for example, um, wireless 4G, 5G, these things, Wi-Fi, and then you want to do some algorithm, run some algorithm in uh, real-time environment, I mean reliable wireless environment, then NS3 is a very nice tool. So all these codes, yes, someone has worked, Nitika has worked on NS2 long back. NS2 is also yeah, good. Yeah, so NS3 nowadays is like, I think 5G is also there. There was a team that was working in NYU, in New York University. They have released a millimeter wave module online. So and the NS3 is completely open source, so you can use this NS3. Obviously, MATLAB is also a very good resource. In MATLAB, the focus is mainly on physical layer. So if you are working in physical layer based thing, probably MATLAB is a very good tool to do coding. And but if you are interested in Mac layer and other above layers, you can make. I mean, NS3 is really good in that perspective. Okay. So there are many example codes also in NS3 that you can familiarize yourself with those codes and then run your own algorithm there. Okay, so let's go to this code now. Okay, so okay, sorry. Yeah. So yeah, it's a very long code. Okay, so initially you will find that there are some has include LT helper, EPC helper. These are basically the modules that I need to do to my coding. So I will request everyone to go to the main part, main, which is at the bottom, I guess. Yeah. So line number 729, int main. Okay, so there the code is starting. Yeah, so it's a one base station and one access point problem. So the number of BS is initialized to 1. And some distance, radius, inter-packet interval, and enable Wi-Fi. Enable fading is true. That means wireless channel fading is also there. So you are familiar with channel fading, right? This relay fading. Okay, please share your screen. Okay, okay, okay. Yes. So you should be familiar with this fading, right? Rayleigh fading and then Rician fading. Okay. So here this fading is also included in the system. So you will see gradually that this learning algorithms are implemented in a very practical environment where all these components are there. Okay. So there is something called fragmentation threshold, RTS, CTS threshold. These concepts. So you are familiar with the concept RTS, CTS in Wi-Fi? I think you have studied, right? RTS, CTS. Okay. So these parameters you can set here basically. Request to send. Yeah. Request to send and clear to send. Yes. So then you see this. These are the Wi-Fi parameters basically. Okay. So you can set this fragmentation threshold and then RTS ETS threshold. Okay. So there are 3GPP parameters, which is basically the parameters that are related to the base station and the antenna base station and the MS. I mean the mobile station. Okay. So the base station is height is 32 and MS antenna height is 1.5, AP antenna height is 2.5, and transmitter power is 46 dBm, noise figure is 5, and the UV ENB, this is the ENB transmitter power. So the base station transmitted power is 46 dBm, noise figure is 5, and for the UV, the transmitted power is 23 dBm, and the noise figure is 9. Okay, so all these documents, all these values, these are taken from some 3GPP reference. Okay, so some 3GPP documents are there. If you try to, I can share you some of these documents. Just a second. Yes. So okay, maybe I'll share you after the these codes are open source. Yes, these codes are completely open source. And the simulator is also open source. You can, anyone can download and use this simulator. This is very useful for wireless. I mean, it's like most reliable, one of the most reliable wireless simulators. Okay, so I will share you this 3GPP documents. So these are basically based on certain 3GPP documents. Okay. So this is pretty standard. This antenna height and AP antenna height, all these things are very standard. Okay. So now you can ignore these things. These are some basic settings. So now what is happening is basically I am saying that the number of nodes is the number of users that a LTE base station can support. Okay. So initially everything is 0. So initially there is nothing with the LTE. LTE, the resources are shared, right? Because there are voice users and data users, so the resources are shared. And Wi-Fi also initially they are initialized to 0. So there is no Wi-Fi user, no LTE user. The system is at state 0, 0, 0. No voice user, no data user. Okay. Then these are also some initialization that I am doing. Okay. And uh, this is the initial value of thresholds. So what is the threshold? Because if you remember that there were two parameters I plus j, and I plus j is less than equal to c, which is the capacity. So corresponding to every value of j, there is a specific value of I. So that's the value of threshold. So therefore, since the value of c we have taken to be 10, it's a small number used for the experimentation purpose. Therefore, there are 10 threshold values, and these are initialized to a random numbers. Okay, and then you are installing the LTE helper. Okay, so this is basically creating LTE instances, and you tell the LTE to use the EPC. So this is EPC helper. So do you know, anyone can answer what is EPC, full form of EPC? Okay, so Isha has asked one questions. So we can optimize according to our requirement. Yes, you can optimize. The entire NS3 block is available online. So if you want, you can download, and then you will find that there is a folder called example. So it is recommended, if you, before using NS3, you go to this folder example. There are many codes, you run them, try to understand them, and the documentation is also available online. So you can use it. Okay, so so these are some other extra parameters like uplink bandwidth. So bandwidth is basically 50 subcarriers. Okay, that is the, what is the programming language? There is another question. The programming language is C++. It is built on C++. Hmm. So the uplink bandwidth is basically 10 megahertz, because 50 subcarriers, and you know in LTE the subcarriers are 180 kilohertz. One subcarrier is 180 kilohertz. So this is 10 megahertz. 50 subcarriers are associated, and the uplink bandwidth is 10 megahertz. Downlink is also 10 megahertz. And EPC full form is Evolved Packet Core. So that's the name for the core network of the LTE. Okay. And then this is the path loss model, log distance propagation model. You might be aware of this model, that the distance and the propagation model, I mean, there is some logarithmic dependence between the distance and the loss. Okay. And the path loss distance model, and this is also reference loss exponent. So it's like 15.3 plus 3.6 log something. Okay, it's something like that. Okay, so these values are standardized. These are 3GPP recommended values: 15.3, 3.76. And this trace fading loss model is the fading loss model that are available in NS3. Okay, so these are standard loss models. And this is also some fading files, some data that is available for fading, that is 3 kilometer per hour. Okay, so it's like pedestrian mobility. 3 kilometer per hour is one user is moving at a 3 kilometer per hour speed, means it is like pedestrian. So this is the fading model, is the fading model that is used for pedestrian users. Okay, and there are some more terms that I am not going into detail of that. Okay, so now you are creating, you are configuring this, and you are creating the packet gateway. Okay, so there is another question, Lakshmi asking 15 to 180 kilohertz. Can you please explain this again? Okay, 15 to 1. Yeah, so 15 to 180 kilohertz. So one subcarrier is 180 kilohertz in LTE. One subcarrier is 180 kilohertz. So there are 50 subcarriers. So therefore, it's like if you if you calculate this, it will come around something like 9 point. I think it will come to 9, and then there are some extra bandwidth that is kept for safety. Then together it becomes 10 megahertz. So you have to basically, this in U integer value 50 means you are allocated 50 subcarriers. So Lakshmi wants to ask one question. Can you please unmute him, Mr. Biplab?
Sir, I have a question. Sir, I have
Yes.
used a radio wherein if I'm on the same frequency, like, and I'm like some channels are there, and a particular channel corresponds to some frequency. So if I'm also on the same frequency, I can talk to. The communication can happen. So in this case, what that subcarrier and this means, can you please elaborate and tell me how it is? I mean, in what sense that subcarriers, what they mean exactly?
So in LTE OFDM, you are familiar with OFDM, right?
I know, but sir, theoretically, I don't know the in-depth thing concept. So
Okay,
can you please?
so what happens is that if you know about frequency selective fading, okay, so if you are having a big carrier, then what happens is basically in that subcarrier, within that carrier, the channel might change very rapidly within that frequency band. Okay, so therefore what will happen is within the carrier, since the channel is changing rapidly, then at the receiver it becomes very difficult to decode it, because the channel condition is very rapidly fading. So what we want to do is we want to get a flat fading system. Flat fading means the fading characteristics is basically relatively less varying with frequency. So therefore, within a single, now if we chop the entire carrier into small subcarriers, then within single subcarrier we have flat fading. Okay, so if we had a big carrier previously, so therefore the channel was varying rapidly. Now within a small subcarrier, the channel is like almost flat. Okay, so that's a good thing. It's like almost like we can deal with flat fading very easily. Okay, because the flat fading, the assumption is within the frequency band, the channel is almost constant. Okay, so that can be dealt easily.
So, sir, okay, you mean to say, suppose I'm dealing with some 283 frequency, I'm talking on that frequency. That's a single channel, right? So in this, I break that into multiple, this thing you're telling.
Yes, that's why each subcarrier band is like 180 kilohertz, which is very less. So within this 180 kilohertz, your channel will not vary much. Channel characteristics, channel gain, if you plot now within channel amplitude versus frequency, if you plot, then within this 180 kilohertz, the channel relatively it will not vary
It's
much.
almost constant kind. That's what
Exactly.
you. Okay.
Yeah. So that
What
makes
I
the life
understood
easier.
is right, sir. What I understood is correct, right? Suppose I'm
Yes.
talking in a radio and I'm adjusting some frequency for some channel, that you are dividing here into sub carrier, sub frequencies of
Yes,
each
yes.
one of
That's
these.
what the principle behind WebDM. In WebDM, we are dealing with subcarrier and individual subcarrier we are allotting instead of
To the
giving a
user.
large carrier.
Oh, okay.
Okay.
Okay, sir.
Okay.
Thank you.
Okay. So that's the fading model kind of, because in LT we use WebDM. So thank you, Lakshmi, to pointing this out. Please feel free to ask. You can, if you want to talk, you can just tell me. I will try to unmute you and then interact with you.
Yeah, sir. Sure.
Okay.
Thank you, sir.
And then yeah, that's how you create a node basically. Yeah, so this using this you are able to create a LTE system. Okay, now what is happening is there is a remote host container. So remote host container is something is it possible to draw? Okay, so remote host container is something like a remote host from where you want to receive a data. Okay, so the remote host is connected to the packet gateway, and the packet gateway is forwarding the data to the LTE network, the base station, and the base station is sending the data to you. You are the user. Okay, so you are creating a remote host container, and then making a connection with the packet gateway, and this is the code for Wi-Fi. So Wi-Fi in AP node create one. So it's as simple as that. Okay, you need to just write this, and it will create a Wi-Fi access point. Okay, then you are creating a AP node, and then installing the internet stack, and then this is your data rate. So the data rate is 100 Mbps. That's your line rate. We call it line rate. Okay, and delay, there is no delay. So there is another question. These codes cannot be implemented by Python or MATLAB. Uh, I think in MATLAB it is possible. We will try to see some examples in MATLAB also. After this example, we will try to see some examples. I have done it in NS3, because the problem I am dealing with is basically resource allocation, right? So that is being handled in the layer 2 of the thing. So layer 2 coding NS3, in NS3 you can that is easier. MATLAB, I think if you have a physical layer problem where you want to deal with physical layer stuff, so then I think probably MATLAB will be a better. But in MATLAB also LTE and Wi-Fi, 5G, all these modules they are there in MATLAB also. Python, I am not sure whether this is available in Python, because these two things are built on MATLAB, and this is C++ based. Okay. So okay, so yeah, so then this is the thing. The remote host is connected to the Wi-Fi access point as well, because my network is like this. So there is a remote host, and from the remote host there is a, okay, let me draw here. Try to draw here. I don't have a pen, so I'm trying to make connections between the slides and the code so that you have some feeling, you have some yeah, solid understanding. So this is my Wi-Fi access point, right? This is the LTE base station. My controller is somewhere here. Okay, controller. Okay, so this is in the core network. This is core network. Core network, and this is known as radio access network, RAN. Okay, so now this is connected to the core network. And the core network, I am talking to a PG, I am talking to a, this is my remote host. Okay, so the remote host is connected to the core network and also connected to the Wi-Fi access point. Now suppose you are the user. Okay, now data is coming from here, not visible, but I am sharing my screen. Oh, okay. Why is that? So the diagram is not visible, what I made.
No, sir, it's not visible.
It's not visible.
Okay. Okay, let me rewrite, let me redraw it. Are you been able to see the diagram now? Diagram is visible, right?
Yes, sir. Yes, sir.
Yeah. Okay, so again I will explain. Basically, yeah. So basically this part of the thing, this radio access, this is called radio access network. Okay. So yeah, so this part is known as radio access network, and then above that, there is a core network. Core network basically deals with these gateways and stuff. Okay, so the core network is connected to the remote host. So remote host is my data source. For example, I am downloading some file which is hosted here. So from the remote host, the data is coming through the core network to the base station, and also there is alternative path from the remote host to the directly to the Wi-Fi access point. Okay, and the controller is deciding which path to choose. You are the user. So you have both the options. You can either download this file from this path or this path. So there are many users like this. So this is the setting. I will go back to the code now. You are able to see the code again. No. Yeah, you are able to see the code. Yes. Okay. Okay. So this is what we are doing. We are creating. Now we are creating this. We are creating this LTE ST Wi-Fi STA nodes. Wi-Fi STA node means users. Okay, so there are some number of users that we are creating, and similarly we are creating some number of users for LTE as well. Okay, what is the next step? We have created the users, we have created the base station, we have created the Wi-Fi access point. Now I need to provide them internet address, right, so that data can flow. Okay, so this is the internet address. IPv4 set base 100. Okay, and then you are assigning this address to the internet devices. So what will happen is that this address 1.0.0.0, 1.0.0.1, 1.0.0.2, these kind of addresses will get assigned to the base station and the users automatically. Okay, and then there is some basic 7.0.0.0 is the basic address, by default address, that is associated to the core network. Therefore you are basically creating a path, a routing table between the user and the core network. So there was already existing path, already existing core network that has some addresses. Now you are creating one address for the users, between the user and the base station, and then you are creating a routing path basically. Okay, so that's what you are doing here. Similarly, log distance path propagation model is calculated for Wi-Fi as well. Okay, so this is for Wi-Fi. Wi-Fi also there is log distance propagation model. The parameter values are different. Okay, and then you are enabling fading. What is the fading? Nakagami propagation model. You have heard about Nakagami fading, right? So the relay fading is like a special case of Nakagami fading. So you are creating Nakagami propagation loss model for the Wi-Fi propagation, and these are your parameters for transmission. Okay, so this is TX power start. It's 23 dBm and TX power end is also 23. So basically, it's a fixed power. You can set these values different also. If you set these values different, then the transmission power will be different. I mean, transmission power highest and lowest will be different. Here we are setting it them same because I want a constant power, constant power scenario. Because if you see the algorithms, there was no mention of power because we are not optimizing power. Okay, so we are keeping the power constant. Okay, and then this is the receiver noise figure, and then that's how you are creating a channel. Okay, so now this is now your Wi-Fi, and as you have seen, this is Wi-Fi standard 802.11g. Okay, so 802.11g is a standard. I think now we have something 802.11h also we have. So 802.11g is little old, but not that old. The first standard was 802.11a. Okay, so one quiz question for all of you. Do you know what are the frequencies in which Wi-Fi access points operate? If
The
you know,
2.4
can you answer in
gigahertz.
chat?
2.4 gigahertz.
Yes.
And
There is another one.
sir, these are like A, G, and there are multiple standards, right? 802.11 something. So the least is 2 giga, I guess. And there are
2.4 gigahertz is one, another is 5 gigahertz. Okay.
5 giga. Yeah.
Yeah. So 802.11. Yeah, Rajesh, you are correct. 5 ESA 2.4. Yeah, those answers are correct. So basically these are the 802.11g I think is the fast standard that has 2.45 both. It operates in both these things, both these operands. Nowadays, I think even this. So there is a very like there is a very funny situation going on, that is now this 3GPP standards, as you see, it has moved to millimeter wave, right? So it are going to higher frequencies like above 20 gigahertz. And now if you see latest Wi-Fi standards, they are going downwards. Okay, they are searching for frequencies in the range of 900 megahertz and something. So cellular 3GPP is exploring the higher frequencies, and IEEE they are now looking for lower frequencies also for Wi-Fi. Because typically, if you see earlier, 3GPP used to operate in lower frequencies like 2G, 3G. These are like in megahertz range. Now they are looking for millimeter wave. But Wi-Fi, on the other hand, they are they are also exploring lower order frequencies. So yeah. So have you any of you have heard about unlicensed LTE? LTE unlicensed? Yeah, WPAN. Yes, that is for the Bluetooth, I guess. Yeah. So LTE unlicensed is actually so these bands are unlicensed. This 2.4 gigahertz, 5 gigahertz. These bands are unlicensed. So if you see, if you can create your own hotspot, right? But can you create your own cellular base station? Can you say why is that? You can create your own hotspot. Nobody is going to stop you. But if you want to create your own base station or tower, then is it possible? No. Okay, so why that is not possible? Because these bands are unlicensed. There is no license associated with it. Wi-Fi bands are unlicensed. So therefore, anyone can transmit in this band. There is no problem. But LTE bands are licensed. So there are regulatory bodies. Frequency. If you when this, for example, these companies, this cellular companies or companies who set up tower, when they want to set up a tower, they had to participate in a bid that is done by some government regulatory body, and then they are allocated some frequencies. Using that frequencies only, they can proprietary bands. Yes. So using that frequencies only they can transmit. Therefore, if you want to set up a you want to transmit in cellular frequencies, you have to buy your own spectrum, and then only you can transmit, because those are licensed band. But in Wi-Fi it's unlicensed, that therefore nobody is stopping you. You can create your own hotspot. Okay. So yeah, Isha is saying, can some proprietary bands to create a BS? Yeah, if you want to create a BS, you have to participate in the bidding, and then if you have to get, you have to buy the spectrum, and then only you can use it. Can we use LoRa one for that? I am not sure. I don't know. I don't know. Long range. Yeah, I don't know. Okay, so anyway, we'll move on. So this is the Wi-Fi standard 802.11g. As you can see, we are dealing with a constant rate Wi-Fi manager. Okay, so the data rate is OFDM 54 Mbps. That is the data mode, and control mode is 6 Mbps. So do you know? So this is the 54 Mbps is basically kept for the data, and 6 Mbps is basically kept for the control signaling. So it is typically a practice. You will see that the control signaling data rate is typically very slow. I mean, this is lower than the data mode. Can you guess why? Any of you? Can you guess why control mode is data rate is lower than the data mode? So typically as it contains preamble, not the data, this is just a control signal. Data mode is a generalized one. No, I mean, the thing, yeah, that's fine. It's sentence control signal, but why the control signal needs to be sent at a lower rate? Okay, so I'll just give you the answer. Okay, I'll just wait for another 1 minute to see if there is any other interesting answer. Yeah, so Isha, what she's saying is correct. It is a control signal. Rang,
Yeah. It doesn't contain any data as such, so it is only like to suppose to control commands. That's it. I mean, doesn't contain any data, so that's why.
yeah, that is okay. But why? What is the problem if you send it at 54 Mbps?
No, that control command doesn't need that much rate, right?
No, what happened? If you send 54 Mbps, then what is the harm? See, the answer is like this. So go back to your initial understanding about the modulation schemes. Okay, take an example of your BPSK versus QPSK. In BPSK, the data rate is low. In QPSK, the data rate is higher. Okay, but what is the trade-off? If the data rate is higher, then the error probability is also higher, because the data rate because the these constellation symbols, they are very close to each other. When the constellation symbols are very close to each other, then there is a high probability that you can misinterpret one symbol as another. Okay, so therefore if you are using 6 Mbps, you are using a basically you are trying to use a lower using a scheme where the constellation are very far from each other. Therefore the bit error rate is basically very low. Now when you are using control signal, you cannot afford to lose any data, because these are control signal, these are very important information. Okay, so similarly you have seen, I have told you about the example of voice and data. That voice, you cannot, voice is like the packets has to come one by one. If you lose one packet or if one packet comes before another, then that's a problem, right? That will create some problem. So therefore in voice also you see that the data rate is small. Whenever there is some critical information which needs to be provided to other people, Control information is a very critical information. You cannot afford to lose any bit of that, because that will, if you get a wrong control information, there your your entire management will be disrupted. So therefore, control signals are sent at a very lower rate so that there is no loss. Okay, but data rate, you can afford to lose some data and retransmit, and that's fine. So therefore, data are sent at 54 Mbps. Okay, so okay, there are few more. Power lost, throughput decreases, constellation is dense, BER is high. Right. This is the point. The constellation is dense, the BER is high. Therefore, 54 Mbps, your BER will be high, and 6 Mbps, the BER will be low. To ensure that the no control information is lost, it is sent at the lowest bit rate. Okay. So now you are creating MAC, Wi-Fi MAC. Now you will gradually appreciate that why MAC is useful. Okay. So you are creating a Wi-Fi MAC, and then you are giving some SSID. Okay. At installing the MAC in the Wi-Fi STA nodes, which is the users. Okay. So you are installing the MAC and Phi to the Wi-Fi STA nodes, and then these are the position allocator. Okay. So NS3 has something called position allocator. Okay. So what is this? This is my position allocator 100 0. 100 0 means I am suppose I am doing everything. I am like plotting those users. I am keeping those users at individual locations. So base station, it's like a XY plane. So the base station location is 100 in the x-axis and 0 in the y-axis. Okay, and this is the height of the base station. This is also set before, and then you are using only one base station, and that is where you are placing the base station. And the mobility is constant position mobility model. So these are the mobility models that are already available in NS3. Okay, so here it is constant position mobility model, means the users are stationary. Okay, everything is stationary. And then you have this is antenna is isotropic antenna. So isotropic antenna means it radiates equally among all direction. There are models for this antenna as well. You have the models for like directional antenna. All these models are there. If you have to just select the appropriate model. Okay, so now what I'm doing is, this is very interesting. So the 3GPP has recommended that there should be no UV and access point within 35 meter radius of a node B. So whenever there is a base station, 3GPP has recommended that within 35 meter radius of the base station, there cannot be any UV. That's the 3GPP recommendation. Okay. So therefore, what we are doing is, we are basically positioning the users in such a manner. So this is my thing. So V1, V2, I am generating a random number between 0 and 200. Okay. So this is a random number generator, rand, and then I'm doing modulo 200, which is basically I'm generating random numbers between 0 and 200, and then I'm checking it is, if it is greater than 35, means the distance between my I mean, basically I'm referring to this factor within 35 meter nothing can be present, and then I'm allocating the UVs randomly within the network. Okay, so these are the UV positions, UV nodes, and then so on. So this is the my antenna height for the access point, 50 meter, 30 meter. This is the coordinate. So the base station is placed in 100 and the Wi-Fi is placed at 50 30. Okay, similarly Wi-Fi, for Wi-Fi area also I am placing within 30 meter radius, because I am assuming that Wi-Fi coverage is around 30 meter. So within 30 meter radius I am placing some MS antenna also. Okay, and then yeah, so these are some similar things, and then I'm installing this stack, and this is my IP address allocation for the like Wi-Fi access point and those users, Wi-Fi users. Okay, so these are some of the similar things. I'm not going line by line, because that will take a lot of time. After all this, what I do is yeah, again I'm creating routing path, so that appropriate data can go from one network to another. Okay, using static routing and default gateway address. So yeah, there are some gateway address, routing path, those are I'm selecting using these lines. Okay, and then finally what I'm doing is attach. Okay, I'm attaching the UV devices with the inode B devices using attach function. LTE helper has a attach function, using which you can attach the devices to the LTE base station. Okay, now what I'm doing is, this is very important. This is what is basically I am trying to, this by these lines, what I am doing is I am trying to mimic this lambda d and lambda v, if you remember. In the presentation I have told you, right, this Poisson arrival with lambda v and lambda d, do you remember? So okay, is there any question? Okay, so so Poisson arrival of users using lambda v and lambda d, that means my inter-arrival time is exponential. Okay, so what I'm doing is I'm creating this thing, this log drand 48. This function basically creates exponential random variables. So I'm creating exponential random variable as to create the arrival time of voice users, and then I'm scheduling one function which is policy choice voice. So what I'm doing here is I'm creating a list of numbers which are exponential apart, which are apart by exponential distribution, their inter-arrival time, and then according to these numbers I am triggering this function policy choice voice, which is what policy the voice will take. Okay, similarly for data I am creating policy choice data. Okay, so these are the functions that will be triggered when I basically when I go for data users. Okay, so voice user, policy choice voice, policy choice data. These things are some config connect thing that is basically it will report the SINR, and it will, for Wi-Fi also it will give some received status, whether packets are received correctly. So these things I will not go detail into it because it will take a lot of time now. So so I will go to this function. Okay, policy choice voice. We'll see what is happening. Okay, so this is my policy choice voice. So any question till this point? So now I have talked enough about the wireless setting. Now you will see that how machine learning is coming into picture. Okay, so so this is the policy choice voice function. What is happening? It's basically initially it stores the old data. Okay, how much what was the status of the old current network. Okay, then it will create this, it will trigger this function, structured PDS learning. Structured PDS learning is the structure ever learning algorithm, that complicated looking algorithm that I showed you, basically using the this gradient technique, that using the gradient information you go there, and that algorithm is, and I'm going to explain. Okay, so this is my structured PDS learning algorithm. So what is happening now? Index is 1. Index 1 means there is a voice user. So what I'm doing is I'm checking that the total number of voice user plus data user is less than threshold. If it is less than threshold, you know what is the action, right? You have to accept, because up to the threshold your action is accept. After the threshold your action is block, right? So if the total number of user is less than threshold, then your action is 2. Action 2 is basically accept. Else your action is 1, which is blocking. Okay, so this part is clear. Now what I do is I am calculating some expression. Okay, so this expression is nothing but the now I have to go back to the presentation again. Yeah, so everyone, yeah, so this is the, I hope the presentation is visible. So you remember, right? These are the things that we are wanted to calculate, and then this is my sigmoid function. Okay, so this sigmoid function, just a second. Yeah, yeah, oh sorry. Yeah, so this sigmoid function, I talked about this sigmoid function. Okay, so this is something like e to the power minus e to the power x divided by 1 plus e to the power x. I think it is something like this. E to the power x minus theta divided by 1 plus e to the power of x minus theta. Similar looking. Okay. So now if you have to do a differentiate because you are calculating the gradient of this transition probability, right? So this is the approximation. So this kind of terms will come into picture, and then if you do differentiate, then what will happen is that you will get this term. Yeah, this is the term. Okay, so that's how it is related. Okay, so that the derivative term is captured here. Okay, and then what you are doing is your threshold is threshold minus multiplying factor, rho is my learning rate, and threshold value 0. So this is nothing but gradient descent. Okay, and then there is some projection operator. If you are falling outside the range, it is basically keeping you back to range. And if the thresholds are also ordered, this you can ignore. Okay, so that's what is happening here. I mean, if you look at the algorithm, it's nothing complicated. It's just the calculating the gradient, and then accordingly you are changing this thing. Okay. Similarly, for index equal to 2, the data user, again, if your total number of users is less than threshold, your action is accept. Okay. Otherwise, it is reject. Okay. So similarly, you have a multiplier, and then you have changing the threshold value using a gradient descent routine. Okay. So now you are calculating the throughput using this function, and then what happen is that finally you are choosing a simulator schedule. This function, what it does it, this is a schedule function. So basically it will schedule an event for you. What is that event? That is an arrival of a voice user. Seconds 00 means you arrive, the event will happen now because the event has already appeared, and then only this function is triggered, right? Structured PDS learning. So within that function, you are creating another schedule event, which is basically just a second. Yeah, which is basically seconds 0.0 means you do it now. What you doing now? You trigger this function. It's a callback function. My callback arrival voice, and S time is the starting time, and E time is the ending time. So ending time means what is the expected departure time of the voice call, and your parameter is 2. 2 is the action. Okay, so if action is 2, then this is happening, else the voice user is blocked. Okay, so now I will see what is happening inside this function. This is the call arrival. This is the voice call arrival. Okay, so one voice call I have admitted in the system. So what I have done is I have checked whether my threshold is within the limit, whether my current total number of user is less than threshold. If yes, I have admitted, then I have changed my parameter for the for the um, for the threshold, and then I am admitting one voice user. So after admitting a voice user, what I am doing is I am checking whether BZLT, if you remember, it was a data structure to say that okay, there is no voice user. So one, I am checking a free server. Okay, so whenever I am finding a free server, I am making that I have found one LTE voice user, and then I am creating a socket. So this will create a socket between at the UV node. So at your user, at your mobile station, it is creating a socket, and then internet IP address, it gets the IP address, and then there is a application installed, sync packet sync helper. That's the application, and then with the remote host you are connecting basically. So this creates a connection between the UV and the remote host. So the UV, the remote host is the sync. So it's like the uplink. Okay, so in uplink you are sending a packet. The packet is going from your mobile to the inode B, to the remote host via inode B. Okay, so it will start immediately and it will end whenever there is a departure. So E time minus S time means the E time is the end time and S time is the start time. So this is the duration. So it will start now and it will over at this point. And what is happening is like I am sending packets of size 50 bytes and the data rate is 20 kbps. Okay, so that's how it is happening. I think Yeah, rest of the functions are similar to this. Okay, so basically for data also you will see that in LTE, if you get a data, so you are doing similar stuff. You are sending packets of size 600 Mbps, and the data rate is 5 Mbps. Okay, so in 5 Mbps you are sending packet to LTE with your data rate is 600 Mbps. Sorry, 600 byte packet size. Okay, so there is a table actually available that corresponding to this 5 Mbps, I mean data rate, what should be the packet size, that table is also there. Okay, so yeah, so that's how it operates. And for Wi-Fi also I will show quickly what is happening. This I have already shown you. Yeah, so threshold value I am not going here, is basically I told yesterday that you need to toss a coin, because with equal probability you need to choose policy P1 and P0. So that's what is happening. And if you get a head, you have a plus sign. If you have a tail, you need a minus sign. So those things are happening here. Okay, this very simple algorithm. Coding wise, that's not an issue. Okay, so yeah, so I wanted to show you the data, so Wi-Fi also, OS, LTE, departure. Sorry, I'm unable to find it now, Wi-Fi. Yeah. So this kind of algorithms, or this kind of functionalities also you can implement there. It's like giving you, it will give you SINR for every user. So for example, you want to implement an algorithm that the user which has the least SINR in LTE, that you will transfer to Wi-Fi. Okay, so those kind of functionalities you can do in this kind of functions are there, which will give you the UI, the SINR corresponding to every UE, and corresponding to that you can, so SINR values also you can access. Okay, so that's it, I think. Yeah, so finally, if you run these algorithms, I'll show you some plots. So if you run this algorithm, then what will happen is finally, this data voice user arrival, those events will be triggered. You can see them on screen, that voice user and data user arrival is happening, and then gradually your, so now if you see, then x-axis, this is number of iterations, and in y-axis there is a total system throughput. Okay, so you see that the structural learning, it's like so number of iterations means number of events, number of arrivals, departures in total. So you see this convergence behavior for different values of mu v mu d is the service rate. So both the scenarios, structural learning is converging faster. And these are also some plots for on the spot offloading, which is the algorithm that is present in today's network, and then some plots related to that also is present here. Okay, so I think that's it overall. Yeah, so if you have any questions. So Asia has asked one question, that can you tell how to create nodes? Yeah, so so now you are seeing my code again. Yes, okay. So node creation is happening here. See, your Wi-Fi STA nodes create in Wi-Fi. So very simple. You just use create functions. Wi-Fi ST node is a data type which is declared here somewhere. Yeah, so this is node container. So there is a class node container, Wi-Fi ST nodes, LTE ST nodes. You have to declare, and then you can write this. What node container create n Wi-Fi. N Wi-Fi is a number. How many nodes you want. So according to that, it will create a node. Okay. Nitika is asking this domain is very even for the base station. Isha, okay. Yeah, for base station also. Yeah, this is the thing. E node B create number of BS. So node container, E node B node, and then you create a node which is the base station. So these nodes are nodes only now. Okay. Now, if you want to make them base station or access point, you have to install certain other properties. So at this point, E node B is just a node. Okay. Now if you now create inode B, now you install mobility into it. Okay, so install LT helper inode B device. So if you do this install inode B device, then it becomes a inode B. If you say install UE device, then it becomes a UE. It's like that. So first it's like a general node, and then you need to say that whether you want it to be a inode B or a UE or a access point. So these functionalities are there. You can specify. Okay, so Nitika is asking, this domain is a bit new for me. Please advise some basic textbooks for getting overall understanding. You should start with some wireless communication textbook, like Sri Vishwanath is one book. I think that is good. But I will also suggest wireless communication textbook is Solaris for digital communication. I don't remember the exact book name now. So there are some famous textbooks for basic wireless communication basically. So those books you can study. So these concepts like cellular communication, frequency reuse, and then OFDM, then CDMA, all these concepts you can read from there. And then I think fading. So if you know these concepts, also you need to study some amount of wireless networks as well, like in Wi-Fi, the CSMA protocol, CDMA, CSMA protocol, CSMA CA, CSMA CD, how these things are happening, IP mobility. So there are many textbooks you will find in internet only. So you have to read those textbooks, and then you will get some clear idea about these things. Also, there are available video lectures also. You can go through these as well. Okay, and NS3 is a tool to Okay, there is another question from Amol. That is, which tool is better for implementation of spectrum allocation based call admission control? Spectrum allocation based call admission control, it depends on which kind of spectrum you are dealing with. So are you talking about LTE Wi-Fi spectrum or 4G, 5G, this kind of spectrum, or something different? So if you are dealing with this kind of spectrum, probably NS3 and MATLAB will be very good. If not, I'm not very sure what should be the good spectrum. But I think NS3, MATLAB in general, for any wireless problem, these are the very, very good tools. Okay, another question is Manish Bhatia. Is any change in simulation results when we considered NRU instead of LTU? So by NRU, you mean new radio, right? Manish? Yeah, Asi Gupta has shared some textbook names, Goldsmith, Rappaport. Yeah, these books are also good. Okay, so yeah, Manish was asking this question. Is any change in simulation result when he considered NRU instead of LTU? I guess he is trying to mean new radio. Okay, so if you mean new radio, then New radio actually, there are two spectrums. One is sub 6 gigahertz band, another is millimeter wave band. Okay, so I have not done simulations for the millimeter wave, but I feel this definitely could be done, and using this code that I presented you, it will not become very difficult to move from LTE to millimeter wave. I did some simulations definitely, and not extensively. Few simulations I did in the millimeter wave setting. That those codes are not in the GitHub, but I feel whatever code I wrote for LTE, I was very easily able to modify that code for millimeter wave, and then yeah, I was getting, obviously the throughput values are very different, but yeah, similar framework could be implemented there. Throughput values will be different, obviously. Okay, any other questions? Okay, so if there is no question, we will take another break of 10 minutes. Then I will try to show some other examples using MATLAB. Obviously, those examples are not constructed by me. It is there in MATLAB. We will try to discuss them in briefly. Okay, so if you have any questions in between, feel free to post it in chat. We will meet again at 4:10. We will have a 10 minutes break. Thank you. So welcome back, everyone. Uh, I will try to share a few more examples, but those examples also use machine learning concepts. So by the way, first of all, am I audible to everyone? I just disconnected my headphone. That's why I'm asking again. Yes. Okay. So I will. Yeah, I will share the screen. So these are some more examples from wireless communication where machine learning has been used. So this is using neural network and other things. So so I will try to go through quickly and give you the concepts, what is happening. Uh, and since neural network is not really my area, I may not know many things. Okay, so we will try to see. We will walk through together and to have a better understanding of these things. Okay, so the first example, I will copy paste the link also in the chat so that you can open it in your screen. Okay. Okay. So deep learning synthesis for 5G channel estimation. You know, channel estimation is a important parameter, important mechanism in wireless communication, where you want to estimate the channel, that what is happening, and then how can you have a good channel estimation. The channel estimation typically is a very tricky procedure, and in 5G itself, 5G, these things becomes much more challenging, because in 5G, if you go for millimeter wave, uh, it is changing very rapidly. Okay, so okay, so there is a good discussion. There can be a good discussion in this area. There is 5G channel estimation. Okay, so channel estimation is basically estimating how the channel might behave, what is the channel condition, what is the propagation condition. Now in traditional channel like 4G and 3G, this kind of channels, in these cases channel estimation was relatively easy. Yeah. Because the channel condition does not vary much. Okay? The channel conditions are relatively better, I mean relatively well behaved. But in 5G millimeter wave, the frequency is quite high, like above 20 gigahertz and so on, millimeter wave. So then what happens is that this channel condition, uh, it varies a lot with time. And if you are like slightly off, for example, you are moving in a car, then it becomes very difficult to do the channel estimation, because in a car, I mean, if you are slightly off from the base station, if you have a for 1 second of obstruction or something, you might be in deep head. Okay, so in 5G the channel changes very rapidly. Even if you are a stationary user, then maybe channel estimation is possible for you. But if you are moving, or even if you are a pedestrian user, then also channel estimation is quite difficult. That's where the need of machine learning comes into picture. So I think yesterday or day before, there was one question that someone asked, that how can I use Q learning for this wireless communication things. So first thing is, you have to first understand that whether learning is necessary, because it's not always that machine learning will improve your performance, or applying machine learning to problem is good, because you have to first identify whether the problem requires machine learning. Now channel estimation is something where machine learning could be useful, because here the conditions very rapidly changes. Okay, so therefore sometimes channel estimation is using traditional technique might not be well. Okay, so I think I talked about multi-arm bandit in my first lecture. Okay, so multi-arm bandit, I will quickly just recap. The multi-arm bandit is a concept where there are like many arms of a bandit, and each arm. So it is like a casino. You are visiting a casino, and there are many slot machines. Okay, so each of the slot machine produces stochastic reward, and then there is something called there is something called mean reward, which you want to maximize. Okay, so now that is the premise of multi-arm bandit. So in 5G also, you can view channels as arms of a bandit. Okay, So for example, you are a user, you are seeing 10 channels. 10 channels means 10 frequency bands, okay, or maybe 10 base stations. There are 10 base stations in front of you. Okay, so you want to select the base station. So each channel between you and the base station, you can view it as a bandit. Okay, and now you want to do is you want to select the channels and do this exploitation trade-off, and in the long run you want to find the best channel. Okay, so this behavior was not necessary in the pre 5G era. This was not necessary because channel estimation was kind of a well-known problem. But in 5G, this channel estimation has become new because it is very difficult to estimate the channel. Therefore, when you apply this multi-arm bandit technique, you are basically avoiding the estimation of channel. You are no longer trying to estimate the channel explicitly. What you are trying to do is you are trying to learn the channel instead of estimating it. You are trying to learn the parameters of the channel instead of explicitly estimating it. Okay, so I will now share a paper with you which was published somewhere around 2018 or something, which uses this kind of techniques in a like a 5G setting. It uses this multi-arm bandit technique for good channel selection. Okay, give me a minute. I will share the paper with you. Okay, so I have shared the two paper name. These papers you can try to read. These are using bandit concepts. So Q learning concepts I have covered. Application of Q learning I have shown you, but there was nothing like bandits. I have not shown you some examples. So these papers you will see that there are bandit based formulations. So there was one question that is, can we use channel coefficient to estimate the channel performance? Yes, channel coefficient you do not know. That is the thing. That's why you need to estimate. So in ML, it becomes difficult. I mean, in ML, that's what you are. I mean, in a way, you can say that you are estimating the channel, but not explicitly. That's what I'm saying. You're not explicitly estimating it. You are trying to learn its behavior through trial and error or using some past data, some supervised solution, supervised learning technique. Use some past data to interpolate and use some neural network to do these things. Okay. So yeah, these papers are very good. You can try to read them. They are solutions. They are proposing some solutions. Okay, so I will again go back to that thing. Start. Sorry, share. Yes. Okay, so here they are doing it. It shows that how to train a convolutional neural network for channel estimation using deep learning toolbox and data generated with 5G toolbox. So if you have MATLAB, probably you need this 5G toolbox and deep learning toolbox to run this example. using a trained CNN, you can perform channel estimation in a CISO mode, single input, single output, and utilizing the physical downlink. So this is physical downlink shared channel. This is one of the physical layer channel for the LTEs for the 5G system. Okay. So what is happening is basically this is a resource grid. Okay. The time frequency resource grid, and then you are selecting some of these resources, the green one. These are pilot symbols. Okay. So pilot symbol means you are sending something to check whether the channel, how is the channel condition. You are sending some bits in the beginning to check how it is, then they will come back to you, and based on that you will estimate the channel. Okay. So this is the pilot bits and the pilot symbols that were affected by channels. Okay. So these are my pilot symbols. So these green ones are the sent one, and yeah, so the green ones are the sent ones, and these are the received ones. Okay. So now what you do is you do a linear interpolation. Okay. So if for example here what is happening is there is a two-dimensional picture from where you are taking from each row you are taking two symbols, and based on the pattern you are basically interpolating it. You are saying that the entire row will be like this. Okay. So this is some sort of linear interpolation. Okay. Okay. So yeah. So now you can use deep learning technique for channel estimation. So this is the channel. So this picture is similar. So this x-axis shows the number of symbols, and y-axis shows the number of subcarriers. Okay. So it's and then you are sending it through a channel, and after sending the channel, the pilot symbols is like this. Okay. And then you are doing a linear interpolation, and finally you are passing it through a neural network which is doing channel estimation. Okay. So what you can do is you can turn this problem of channel estimation into an image processing problem, because ultimately it's like some image you are passing, and then you are trying to make this image finer. Here you see that there are sudden jumps. So these jumps are avoided here. Okay. So using 5G toolbox, you can customize this. The data is split into two parts: training data and validation data. And then based on that, yeah, you are doing the neural network training. So the neural network is basically given some input, and then based on the input, it is trying to minimize the difference between the output of the neural network and the ground truth, and following some gradient descent update, and using that it is optimizing its parameter so that you get a better output for the channel. Okay. So the neural network training consists of these steps. Initially you generate the data, and you divide the data into two sets: training and validation. Okay. So some data is training data, and some data is validation data. So some data you are using for training, and then you validate in between. I mean, you train and validate. That way these things go on. Okay. And then you define the CNN architecture and specify some training options, optimization, and learning rate. Okay. So yeah, so the network can accept this grid 612 by 14 by 1 grid, that is 612 subcarrier, 14 WebDM symbols, and 1 antenna. Okay. And now what is happening is that the CNN creates resource grids at 2D images. Okay. And then the training data is converted from a complex 612 cross 14 matrix into real valued this, because the symbols are like complex symbols. Okay. It has some IQ component. So the I components are presented in a matrix, and the Q component are presented in a separate matrix. Therefore, it become a real valued 612 by 14 by 2 matrix. Okay. And then that 4D array is input to that neural network, and the neural network does some processing here. Yeah, there are certain layers like padding, and then these are the ReLU layer, and then regression layer. So these are the inside phenomena of this, what is happening in the CNN. Okay. And yes, so here it's like number of examples per batch, splitting the data into real and imaginary grid. Okay. And then concatenated it so that you get a 612 by 14 cross 1 cross 2n. So it becomes a 4D data. But underlying thing, what is happening is you are basically optimizing you are predicting a model. Based on that, you are finding the output, and you are checking that what is the difference between the output and the ground truth, and based on the minimum, it means based on the minimum mean square error criteria, you are trying to make the model better and better. You have some data which you are dividing into training data and validation data. Okay, so the training data is validation data. In the validation data, you are gradually evaluating, and so approximately 5 per epoch. Okay, the validation data is used for monitoring the performance at regular intervals, defined by this approximately 5 per epoch. So this is one example for doing that. Okay. So I am not going into detail of this because CNN, I'm not an expert of CNN. Okay, but I think this is a very good example. You can look it at your own time if you are interested. So I will move on to okay, any question regarding this? Regarding this or anything in general? So what I wanted to say is here the technique that has been used is a deep learning technique based on supervised learning, but you can also use RL based techniques as well, and deep learning could be useful in reinforcement learning also, like this neural network kind of theories are also useful there. Yeah, so the papers names which I shared with you, these are essentially multi-arm bandit problems, so they are also doing RL stuff. So low complexity, low regret, link rate selection. Yeah. These are typically useful for millimeter wave kind of application. There was one question regarding call admission control. So call admission control, basically it's a very old problem, but as new networks are evolving, as millimeter wave is coming up, this call admission control, it becomes okay. So Aviranjan is asking to share again. Which one? I don't know. Maybe I'll share this. I mean, I shared the name of these papers. I'll share it again. Probably he missed it. These are using RL concepts to channel selection in millimeter wave. These papers are using techniques like Thomson sampling, and then UCB. UCB is your upper confidence bound. Okay, KLUCB. KLUCB is a very new, nicely. I mean, it's a new algorithm. Upper confidence bound is something like what you do is the idea. See, the idea is the mathematics might look a little difficult, but first, if you have a good intuition of what is happening, then you'll be able to appreciate it better. So UCB, what happens is, the intuition is very clear. Intuition says that when you have a estimation, okay. So I think by now you are familiar with the law of large number, okay. So what law of large number says is, if you are having like tossing a coin 100 times, then you are taking an average, then how many heads has appeared, so that will calculate to the true probability of head, right? But you will see that gradually, as the number of observations are increasing, your reliability of the value also increases. So that's the basic fundamental thing about UCB also. UCB says that, okay, you select the one which has the greatest highest mean, but also with a pinch of salt. What is the pinch of salt? Pinch of salt is a confidence bound, that I have selected this arm 10 times, so I am not very confident about it. Okay, so my confidence bound will be higher. But I have selected this arm 100 times, so I am very confident that whatever I have measured is actually very close to the true mean. So this is similar lines to the law of large number. Okay, so that's why the upper confidence bound is lower. Okay, so that's how. Yeah, so I will share the so someone actually asked me regarding this paper in the first lecture. I'll share the paper link for UCB That's a very, also it is available in Sartan and Barto book also. You can read it from there also. That is also fine. That book link I think I have shared with everyone. So UCB, and then there is a variation of it known as KLUCB. Okay. So the KLUCB is you use the Kullback-Leibler distance, that is known as KL distance, instead of the usual upper confidence bound. So that therefore the problem becomes little bit complex. Calculation becomes little bit complex, but it's like very like it gives a good confidence bound. Okay. So yeah, so those are the concepts that are being extremely useful nowadays in wireless communication setting. Okay. So I will go for another example. Just a second. Yeah. Sharing the link for this. So it says that design of deep neural network with simulated data to detect WLAN router impersonation. So basically, this is a problem to detect if someone has created their own WLAN router. So this is the scenario basically. So there is an observer which observes. So there are some routers, okay, and they have some certain MAC address associated with it. And then there is an unknown router, okay, and you need to find out that if there is any one guy who is trying to pretend to be you, but not you. Okay, so yeah, so that's what they are doing. This is an observer. These are the routers, and then there is an unknown hotspot who is saying that okay, my MAC address is somehow he got the MAC address of this one of these guys, and then he is claiming that I am one of these guys. Okay, so how to detect it? That's the thing. So it uses some concepts like RF signature. Okay. So RF signature is something which you can think of as like dependent on the channel condition. Depending on the channel condition, this RF signature is varying. Okay, so RF signature of the radio link is a function of the channel conditions. Okay, so MAC address and IP address, SSID, these are not effective in detecting such an attack. Okay, because this can be like one can get information regarding this by some means, and these are static information. Okay, but RF signature is something which is dependent on your location and the location of the access points. Okay, so therefore it is not possible to impersonate these things. Okay, so as you have seen here, written the wireless transmitter receiver pair creates a unique RF signature at the receiver. Okay, that is a combination of the channel and RF impairments. Okay, so using this RF signature and applying some DL algorithms, they are trying to find out this parameters. So again, I will not go into detail of this because there are too many things are there. Basic idea is you can use deep learning based techniques to detect if someone has created a WLAN. So this is an example which covers WLAN network. The previous example was RF. The previous example was for something for cellular networks, okay, channel estimation techniques, and the one I showed you is here is it's a Wi-Fi access point and LTE base station Wi-Fi access point problem where there are users which want to get associated to one of these things so that a certain metric is maximized subject to a constraint on the blocking probability of you want to maximize the total system throughput subject to a constraint on the blocking probability of voice users. And I showed you that how you can create a network using NS3. Okay, you can create a network, you can create a nodes, and then you can you can tell that these nodes are Wi-Fi access points, these nodes are LTE base stations, these nodes are user. You can assign mobility model to them so that these are stationary. So have you heard of something called bouncing? I mean, there is a mobility model given by 3GPP, which is like there is the users move in a circle, and whenever they hit the periphery of the circle, they will bounce back to the original in that circle again. Okay, so this kind of models are also there. You can implement this kind of models also within the NS3 setting, and it will give you reliably. It will allow you to 3GPP recommended parameters you can implement using NS3 in the in cellular. So these are some of the maybe some of the documents I will share where these guidelines are given, so that while doing simulation, because sometimes what happens is that we do simulations, but the simulations might not be according to the standards. Therefore, the reviewers will ask questions like, okay, so you have done simulation, but why your antenna height is not 32 meter? Why your base station height is not 2 meters? Something like that. These questions also come. So it is always better to go through these documents carefully, so that you are standard compliant. Your simulations are in a reliable environment, and NS3 will allow you to do that. I think it is possible in MATLAB as well. So now I'll share some of the standardization documents also. Give me a minute. Yeah, these are two documents that I have shared. Okay, so here you will get some mobility models for heterogeneous networks and some physical layer aspects also. NS2 GitHub link I have shared actually. This is not NS2, okay, Viranjan, this is NS3. I will share again. So here you can get code for Q learning as well as this structure aware learning. These two algorithms are put there. So these two documents, there are many more documents in 3GPP website you can find. So please, whenever you are doing simulation, I would suggest that you refer to these documents. These are very useful. Okay. Okay. So any other question if you have in general, you can ask now. I think yeah, I have shown some examples. This router example and channel estimation, you can have a look in your own time. I think those also, maybe someone if you is interested in deep learning application in wireless communication, that will be useful. Okay, so you can ask some questions if you have any. Future directions in physical layer aspect is a question asked by Rajesh Ramanathan. Obviously, channel estimation is one of the future direction where in millimeter wave the channel estimation becomes a new problem. Okay, because yeah, and also I think there are certain research work going on in the direction of carrier aggregation, and so another thing which I will say, for example, when you have a millimeter wave base stations, and then the 4G base stations will not go away, right? Today's 4G base station will also remain. Okay, so now you are having millimeter wave also. Millimeter wave channel characteristics, physical layer is entirely different from today's 4G base stations. Okay, so now if you have many different kind of users like mobile users, stationary users, then which network do you prefer? Okay, so that will depend on your channel condition and physical layer aspects of millimeter wave as well. And sometimes it may be better to work in the millimeter wave mode. Sometimes it may be better to work in the sub 6 gigahertz mode. So I think these problems are still valid. I think in physical layer aspect, I think D2D communication also might play some role. And Wi-Fi also nowadays, as you know, that Wi-Fi also creating a new band in the cellular near to the cellular communication bands. So how that spectrum, how do you do channel allocation in that spectrum? This kind of issues will definitely be there, and email might be helpful. Does it answer your question, Rajesh? Okay, thank you. Any other? Please suggest textbook for implementation code for CSE specifically. Implementation code. I don't think there are textbook for implementation. I don't know about textbook. Maybe that is there. For implementation perspective, I think it's better to do it on your own. I mean, these codes are not that difficult. Okay. Admission control, as I have already showed you today, right? This, like, you define some actions and then you create a path. You populate the routing table. So I think it's better to do your own coding. It's nothing but simple logic probably. So I don't know of any textbook. Probably I have to search. For implementation purpose, I don't know, but I have given you some like references for theoretical aspects of call admission control. So both these aspects. Okay, so references. Okay, Amol is asking for references. I think I have shared already, right? Some papers with you. The beginning of the session. And one technical report by small. Yeah, one technical report or a small book by Gair Kul also. I've shared. I'll just copy paste again. So I have just shared it again. Okay, so these books are basically, most of these papers are based on Markov decision process for this call admission control problem. Also, you can, there are certain papers on MDP, sorry, RL side also there will be some papers, but all these problems that are convertible to Q learning and RL settings, because they are dealing with MDP. So if you remove the assumption that the call arrival rates are not known to you, then you will have a RL problem. Okay. So particularly this book, I think it's a very good book, Monotonicity in Markov Reward and Markov, like this book by Gair Kul. So this book also you can find some these things. Any other questions? Which journal for CSE? If you are looking for wireless, if you are looking for call admission control problem in the wireless networks, then you can look at journals like Transactions and Communication, Transactions and Vehicular Technology, this kind of journals. But typically, previous works in call admission control, you can find it journals like Operation Research and Mathematical Methods of Operation Research and Performance Evaluation Elsevier. In this kind of journals, some of the papers, earlier papers on call admission control was published. So you can refer to that as well. Any other question? So I think this overall, whatever we covered in this 5-6 days, I hope that these concepts will be very useful to you. Also, I tried to cover the main concepts of reinforcement learning like Q-learning and multi-arm bandit, and I also provided you some references for that, both theory papers and some practical examples, so that in future you will be motivated to work in these aspects, because you see right now that there are certain application of this learning phenomena in wireless networks for solving wireless network problems. And as I have told you that in channel estimation, for example, initially the channel estimation paradigm was very different. Nowadays in millimeter wave, channel estimation requires fresh investigation, because sometimes they are formulated as multi-arm bandit problems where each channel is viewed as a bandit and you are trying to maximize trying to choose the bandit which will give you highest average reward, which is like highest average data rate, something like that. So instead of explicitly doing channel estimation, you can go for multi-arm bandit kind. That is because channel condition varies very rapidly. Okay. I think with this you will be able to embark on your journey towards finding research problems which you can solve using machine learning techniques. I think that's it from my side now. Thank you.
Thank you, Agadip sir.
Thank you. Thank you, Aman. Okay, there is another question. Apart from channel estimation, which another parameter we can consider for ML? There are a few more fields which I'll mention, which you can look at. There's something called ultra reliable low latency communication, where for example, the reliability of the channel needs to be very high. I mean, so sometimes what happens is we want to, for example, minimize the average delay. Okay. Now, when you want to minimize the average delay, what may happen is the higher order movements of the delay, like variance and third order movement and so on. Those have, I mean, it has a higher variance. So those moments are not taken into capture. Now, so if you want to minimize delay and if your solution has a higher variance, okay, then it will lead to high jitter. That's also not good. So when you go for ultra reliable low latency communication, then your jitter also has to be bounded. Therefore, the traditional methods of RL does not work well there, because you need not just only need to minimize some average parameter, you also need to constrain your variance and other higher order moments also. So in this type of application also, there are other RL aspects and other ML architecture that we also useful. So ultra reliable low latency, mobile edge computing, and also IoT. In IoT also nowadays machine learning is very useful. So these are also some of the areas that you can pick for your research problem. So Amal is asking for the contact information. I think our contact information is available with the organizers, as well as all the speakers who have talked their individual websites. You can find the contact information. if you are interested, or if you have any specific questions, you can ask us. You can send a mail to us also.
Participants, we have shared the feedback link in the chat box. You can fill the feedback form. Good afternoon to all esteemed dignitaries, speakers, and participants. Now we are moving towards the valedictory session of this joint faculty development program on machine learning application in signal processing and communication engineering. We have with us Professor Ratnajit Bhattacharjee, sir, joint coordinator of this program. Dr. Argadip Roy, sir, joint principal coordinator. Our expert, Dr. Konda Reddy, sir.
Do you have the coordinators from the other participating academics joining?
Sir, no one has joined from other academy till now.
Yeah, but time was given at 5, I suppose.
Yes, sir.
So still 5 minutes is there.
Yes, sir. Sir, we will be waiting for a few more minutes.
Yeah.
Okay, sir.
And you can send an invite also to at least Dr. Bharat, Professor Savla, and all others who are the part of this program.
Yes, sir.
So actually, referring to Asa's question, apart from channel estimation, what are the other things we can consider for ML? Actually, in the yesterday's talk, with the slides I have shared, there was a survey paper, right? There was a actually IEEE Communication Magazine paper. So you can go there and then you can find there are some potential directions that has been described in that paper as well. Okay, and also they have classified that how there are like supervised, unsupervised, and reinforcement learning. They have classified what are the applications. So maybe you can refer to that paper as well to find out what are the future directions. Also, I would say that keep an eye to the 3GPP website, because there are certain discussions going on regarding what kind of new problems that needs to be standardized. So these issues are also being discussed there. So if you look at the discussions 3GPP is having, you will be able to familiarize yourself with the newest topics that the wireless community is working on.
Can we start our valedictory session?
Sir, we are waiting for Bharat sir to join.
Hmm. Dr. Bharat is joining,
Yes, sir. He'll be joining, sir.
and from MNIT, I think Dr. Nanda.
Yes, sir. Ha.
Please check once at least the joint coordinators from the other participating institutes. If they can join, it would be nice.
Sir, we are trying to connect with all the sirs. It will take 5 minutes approximately.
Firuza? Firuza?
Firoza ma'am, are you there?
No, possibly not there. Anyway, any information about the other coordinators joining? Otherwise, we can actually start this valedictory.
Yeah, good evening, sir.
Yeah.
So this is Firoza. Sir, actually, Bharat sir asked us to start the event. Sir is joining in the meantime. And
Okay.
sir, the phone of the joint coordinator from NIT Patna, it is not being connected.
Hmm.
So we are trying, sir. But Bharat sir told me that he is joining in another 5 to 10 minutes. So in the meantime, we can start the event.
Yeah, this valedictory, as I understand, it is the session where actually we try to get the feedback from the participants and it would be very nice if some of the participants come forward to share their experiences, tell us which are the things they liked about the course and the areas where we can improve in our later courses. So
Yes, sir.
I would request the dear participants, because we have gone through this entire program, there have been, you might have come to know that IIT Guwahati has suddenly been declared as a containment zone, and our EICT staff, I'm very, very thankful to them. In spite of this, they could conduct the course. They could not enter their office. So everybody has taken this challenge and the course was conducted as usual. So I'm very thankful to my panelists as well as the colleagues from ICT Academy. Uh, so I'd request some of the participants who would wish to share their experience may please unmute themselves. First, they raise their hand so that our people can unmute them and they can share their experiences and give us their valuable feedback for our future courses, of course, how we can do it in a better way. I could see Dr. Rakesh Ranjan has joined. Yeah.
Yes, sir. Yes, sir.
Yeah, good evening, sir.
Yeah, so we have just started because it's already 5:07 and would definitely request you to say a few words. So if any.
Hello. Thank you, sir. First of all, I would like to say thank to all the organizers, Professor Ratnji Bhattacharya sir, and all the joint principal coordinators for this program. Such a beautiful program which is based on machine learning and its application in engineering, especially communication and signal processing. This program covers a lot of aspects regarding the machine learning, and I'm sure all the participants have definitely benefited with this type of program, and we all are expecting that such kind of program should be should occur in the near future also, so that as the machine learning is the demand of the current era of the research and as well as the day-to-day life activities. So this would be a great help to all the participants and other those who were not able to attend this program because of some reasons. I'm also thanking to all the CIs of different ICT academies, those who are involved in this program. By saying these few words, thank you very much, sir.
Thank you very much.
Thank you, sir.
So Firoza, can you see if any participant would like to share their views?
Hello.
Yeah.
Yes, I am audible. Yes, good evening, all the respected professor from different IITs and NITs. Hi, this is Bhaskar Kapoor from Maharaja Agrawal Institute of Technology, Delhi. Actually, I am a PhD student from GGS Indraprastha University, Delhi. So, about 1 year ago, in the pandemic situation, I joined a program by EICT, IIT Roorkee, in which I learned machine learning concept and hands-on. And this time, I am again got this experience, the projects and the programming course shared by from the various IITs person. Actually, I'm a private engineering college student, so it is very difficult to collaborate with all the NITs and IITs person. So this program, I'm very enriched with the knowledge shared by all the professors. And thank you, EICT Academy and all the NITs and IIT professors. Thank you so much.
Nice to know that you actually got benefited, and this is why every summer and winter we take this initiative, we work
Yes, sir.
together to come up with such courses. Any other feedback, please? Any other?
Yes, sir. Actually, I'm looking for the program specially designed with machine learning and signal processing. Actually, I'm working in EEG area, so this is a very rare course. So this program, obviously, I find very benefit, and I got experience so that I can apply all the concept in my PhD work. Thank you so much all. Thank you.
Good afternoon. Hello.
Sir, I have something to say.
Yes.
Good evening to all the faculties over here who have given their best. I mean, this is a like we could know everything what is ongoing research, and the faculties who taught, they made sure that we understand well, doubts were cleared very well, and the system course was organizing well. So I think this should be organized very often so that these kind of courses will help us out.
Thank you. Thank you for your encouraging words and positive feedback. Anything would like
Good evening, sir.
you would like us to improve, particularly any suggestions?
I don't think anything like that for improvement, because everything was good. But the time duration was too long. It can be per day, 2-3 hours session. It will be helpful because we can grasp things in a better way. That's one thing. But since you have to, so many things have to be integrated. I think this will be like this only. I mean, nothing much to be changed.
Thank you. Thank you.
Thank you, sir.
Good evening, sir. I am Aviranjan from NIT Patna, PhD research scholar. I am also going through from 3rd to 8th January. So I am also doing a deep learning based channel estimation resource allocation. So I also benefited from the insights from like Dr. Mitul Ahirwar sir from Manit Bhopal, from linear regression to multilinear regression. In Argyadip Rai sir, he also taught us reinforcement learning, Q learning, the various LTE, Wi-Fi, HetNet selection. So these are very also Rakesh Jha sir from Triple IDM Jabalpur. He also taught us a very nice way the also we come to know about the 3GPP, that the precise information we can get from the 3GPP and ITU, and from then we can start our research. So this all information I was not knowing earlier. So thank you for knowing all the information from this such a nice FDP organized by IIT Guwahati. I also thank to Konda Reddy sir. So I asked so many questions. So he answered all. He sort out all the my confusion and the doubts from how the gradient descent, linear classifier, bilinear classification, multi classification. So I am very thankful to Konda Reddy Mapuri sir. And finally, I am thanking IIT Guwahati sir because I learned so many things, sir. Thank you, sir.
So Dr. Bharat has just joined. So we were going through the comments and feedbacks from the participants. So I would also request Dr. Bharat, the CI for NIT Patna, if he wants to tell anything to the participants this valedictory session.
Thank you so much. I'm very sorry that I don't know how to have I missed to join. So first, please accept my excuse for not joining on time. So really, it was a hectic faculty development program, and after even though in an online session, I can understand that since morning till evening, continuously watching through the screen and try to understand all the things and grasp all the things and be online continuously with the experts. And so it's really good for the participants that they are continuously be online with us. And we are very thankful to all the experts that who has taken out time and be with us for the whole last 6 days and share their expert knowledge with the participants. So on the behalf of NIT Patna and other academies, we are really thankful. And I especially thanks to Professor Ratnajit Bhattacharya that who took this initiative. And even in this inaugural session, he said that this is the first time that which we are organizing and this program. And at the end, we can say we have conducted a successful FDP on machine learning applications and signal processing and communication engineering. And I was also listening some of the audience or the participants' thoughts, and they are all appreciating. So it's really an honor to listen all these such good words from the participants that they are appreciating our efforts, and we will surely continue this type of efforts for a long. And
Yeah, so
with this, yes, sir.
We have the very next program again. I think you and me will
Yes,
have
sir.
to coordinate it. That IoT from
Correct, sir. Correct.
February.
Sure. Yes, sir. February
Yeah.
14 till 19. Yes, sir.
15. So we would expect some of the participants who are joining this program will also be present there.
Yes.
And we'll try to deliver our best. These are the areas, particularly in the domain of electronics and communication engineering. These are the upcoming areas, and we should embrace them, and we should bring expert people, listen to each other, and develop expertise. These are the platforms through which we older faculties also learn a lot of things by interacting with our new researchers in which direction they are thinking. So it's not necessarily that somebody is giving lecture. I consider it as an interactive platform where we exchange information and learn from each other.
Yes, very true, sir. Yes, I agree with Professor Ratnajit Bhattacharya that this is not just a teaching, and it is a platform where we are also improving ourselves and increasing our domain knowledge in multidisciplinary areas. And nowadays, that it's not only a domain knowledge that it is required to grow in your field. You need to have the all such nearby areas knowledge, like multidisciplinary knowledge, to grow. So yes, it's very true. And and yes, as sir has already said, I will also like to just mention that from February 14 till 19, we are having another FDP, that is the IoT application for smart systems or smart systems. And I hope that most of the people will join uh, that FDP, and they will also circulate it to their colleagues. So this is our request. And with these words, I will really thankful to all the of my colleagues, that all the CIs, all the joint principal coordinators, and all my colleagues that who have helped us to reach to this number. Thank you so much. And once again, thanks to all experts and all the participants. Thank you, sir. Thank you, sir.
Thank you, sir.
I think Dr. Nanda has also joined. So
Yes, sir.
if you would like to. Dr. Nanda, please.
I am thankful to Professor Ratnajit Bhattacharya. It was for designing such a nice program on this aspect of communication and signal processing. It is first time such a program has been designed, and from all over the participants joined at our academy, they all have appreciated. It has thoroughly been designed by you, sir, and several aspects of biomedical signal processing, seismic signal processing, and many applications, particularly in signal processing and communication, have been thoroughly covered. the laboratory sessions are also very good. They were been personally been taken care by the experts. So I am very much thankful for such a wonderful FTP, and it is my fortune to work with all the other co-CI of the academies to conduct such a good workshop. Thank you, sir.
Thank you, sir. Actually, I designed the course, but I'm thankful to the experts who has really given life to this program. And one good thing is that we did not have any refusal. Whoever we knew they are expert in that area and we approached, they happily agreed. So it's a good fortune for us. And particularly, I should thank my colleagues from Mehta Family School of Data Science and Artificial Intelligence. They really worked very hard, and they came forward even to conduct the hands-on themselves. This was a very welcome sign. Dr. Mopari Kondareddy, Dr. Devango, Dr. Ridham, and Dr. Argadeep, they really worked hard for this course, and all other experts, definitely they have done their best, and that's why I'm very thankful at my personal level that at least the candidates who joined this program, they got benefited. So if is there any further comment from anybody? Please. Any participant, any expert would like to make any comment? So if not, I hand over this platform to Firoza now. Let her make her formal announcements and other thing. And once again, thanks to everybody who has directly or indirectly contributed to the successful conduct of this program. And in future, we look forward in conducting similar programs which will add value to our esteemed participants for the course.
Thank you, sir. So on behalf of all the Electronics and ICT Academy at IIT Guwahati, NIT Patna, IIT Roorkee, IIIT DM Jabalpur, MNIT Jaipur, we would like to thanks all for joining us for this event. Thank you for being a part of this event. We have all really enjoyed, and the way the course has been conducted. We also have learned a lot from the participants. There were very good queries as well as very good feedback that we have received. Thank you. Again, this is an important announcement for all the participants that the feedback link has been shared in the drive. Those who have not given their valuable feedback, we request you all to please give your valuable feedback through the link that has been provided. The course materials are also been provided in the drive. I request you all to please use the course material for your future reference. The video lectures are uploaded in the YouTube link. So you can always use the YouTube channel for your study reference. Regarding the certification, as announced earlier, the certification will be released in phased manner after 10 days. We will calculate all the attendance and all the other assignments and all. After that, we will be releasing the certificates after 10 days in phased manner. So it may take 5 to 6 days of time to get all the certification. Please have patience with us.
Ma'am,
So,
one question. Ma'am, I did not attend MCQ first one, so I will not be getting certificate. Is it like that?
Ma'am, it will depend upon your performance in the second MCQ and your attendance. So it will be like there is a calculation based on which we will decide.
Okay, and ma'am, can you please share again the drive link in the mail once again, if possible?
Okay, the drive link, it is already in the Telegram group. If you go in the Telegram group, the drive link is provided. We will again share it. I request Kaushik, please, you can in the chat box share the drive link, please.
And
Again
the
for the
YouTube link
participants.
also for watching the videos again, if possible.
Okay, I request Kaushik to please put the drive link as well as the YouTube link in the chat room.
Yes, ma'am.
Thank you so much, ma'am.
Yeah, okay, thank you. So, with the permission from all the principal coordinator to joint coordinator and all the expert, we can now end the validatory session. So thank you all for joining us. Looking for future courses also, we would like you all to please join us. Thank you.
FDP ఊరికే సర్టిఫికేట్ ఇవ్వట్లా ఈయన కొడుకులేమో FDP అటెండ్ అవ్వమంట.
The link will be active for another 5 minutes. So we request you all, you may all can disconnect. Thank you.
Thank you, Firoza. So we can
Thank you, sir.
disconnect now. We can disconnect now.
Yes, sir. The link will be active for another 5 minutes. Yeah. Thank you, sir.
Okay. Thank you.
తీసుకుని వెళ్ళిపోతాను. లేదులేమ్మా, లేట్ అయిపోయింది పని.
So I have shared the drive link in the chat section. So participants, you can find the drive link over there. And I'm also sharing the YouTube link in 1 minute. So participants, those who do not have the drive link and YouTube link can find the link in the chat section. You can directly click on it.
Sir, again you have shared the same thing. I mean, drive link. You didn't share the YouTube link.
Okay, okay. Yes, now I have shared the YouTube link. Please keep the YouTube link for your future reference. You can see all the videos and the lecture sessions over there. Whatever you have missed, if you want to revisit it, you can revisit it through the YouTube channel.
Sir, once again, in that third day is missing.
Third day missing. I have to check it. It shouldn't be missing. It should be there in the our channel only. Maybe it has missed in the adding in the playlist. We have not added it in the playlist. It should be there in our channel only, in ICT Academy channel.
Okay, sir. I'll check it out. Thank you so much. Yeah.
Yeah. So participants, I am ending the link now, and I'll be closing the link. So thank you all for attending this wonderful session on machine learning. Thank you, participants.